Hello and welcome back to BoneHeads, or should I call it Cartilage Heads for this episode. I know it's been a while, but we're finally back, the greatest paleontology podcast there is, talking about all sorts of things that interest us as paleontology students ourselves. I'm Ben,
Eddie,
the shark.
I'm Hamza.
And yeah, so this is obviously our Shark Week special, which is why we are the Cartilage Heads for this one episode. And we've got a great episode planned for you. All sorts of shark discussions. We've been doing lots of research on sharks. I've been researching for Shark Week videos.
been doing it for a little while, I guess.
You've done your entire dissertation on sharks, so resident shark expert right here, as you can tell from the outfit.
And then I've only just touched in the area of sharks, but I collect them.
Yeah, he's found many fossil sharks before.
Your video debut was Hybodonts.
It was.
Yeah, that was.
It was for Shark Week.
I mean, your art's been in some videos, but yeah,
But the
last Shark Week
it was the last Shark Week I joined.
was
so yeah.
go watch that video. Well, watch this video first, and then watch that video if you haven't. We went to the Isle of Wight and looked for Hybodonts, so which are Jurassic to Cretaceous shark relatives, and we've actually got some fossils that we found in that video. The same ones?
Possibly.
Yeah.
Yes, we have photographs of them as well.
But we'll be showing you some real shark fossils that you found and you found.
Yes.
Later on in this
And
video.
Hopefully later today will also be fun.
Yeah, so right after we're recording this, we are going to a locality here on the south coast of England where you can find 45, 46 million year old shark teeth, and hopefully, with any luck, we'll find some ourselves. That's going to be another video day after this one, if everything goes to plan.
The weather's not too good, but
yeah,
it's in our favour.
Listen, after we went in snow, I can't complain about the weather anymore. It's just...
Yeah, fossil hunting in snow was quite an
really
experience.
fun. I liked it.
It was.
Slippery.
And then I got cold.
Yeah. So anyway, we have some explaining to do, I think. Where have we been for the last nearly 4 months? Has it been now?
Yeah, since Abingdon, so
Oh,
that was
wow,
like
yeah.
April, March.
Yeah, so I think that was our 10th episode of Boneheads, right? It was the
Very
live one.
busy and very hectic.
Yeah.
It was-
Had dissertations in April,
Yeah.
and then straight after that, we were off to Germany, which hopefully we recorded a lot of videos for that. You might have seen some stuff on Ben's Instagram.
Yeah.
That was
hopefully,
an
if you're following
amazing
me there.
trip.
Then we had coursework,
Yeah, and
Many
and then
coursework.
exam, and
Yeah.
then we wanted a bit of a break.
Yeah, so it's just been very busy university stuff for us, but we finished our last undergraduate year of university, so we've all completed our paleontology degrees now, which is very exciting. We've got graduation in a couple of weeks, and yeah, we handed in our dissertations, which you'll talk more about yours in a moment. I did my dissertation on an ichthyosaur, and
I did mine on a little crocodile.
Damn, I didn't know it meant shark lizard.
yeah, I mean, it basically is a shark, but
Fishy
a
lizard.
reptile. So, yeah, yeah, and then we had a university trip to Germany, which, yeah, as you said, we recorded a lot there, so we're going to have a dedicated Boneheads episode, potentially 2 episodes, depending how long it ends up being. But we went to all sorts of amazing places. We went to the Messel pit, which has got
Solhofen.
the Solnhofen limestone quarries.
Yeah, some
Went to
early Jurassic Dottenhausen.
Posidonia Schiefer quarries.
And we got to do our own fossil hunting, so we've all
Oh.
found like ammonites and such.
Dude, there's a bit of an impact pressure behind your pen.
Oh, is
Just
it?
behind the headphones.
Oh, I can't see.
Went
Oh, yeah, that's right.
Yeah.
We went to an impact site of a meteor. So
Yeah, so that's some.
Great.
That's a bit Martil for me.
I don't think the camera can pick up because it's quite bright, but
Yeah, it's basically lots of fragments of like rocks that were ejected up into the air.
Yeah, I think I like the
From an asteroid
description of it.
impact.
Like, if you dropped a hammer on a pane of glass,
Yeah,
that's essentially
that's
what
what
it
you're-
looks like.
yeah.
So that's really cool. So yeah, we'll be
we
Yeah,
didn't sadly
yeah.
get to see the actual
Well, a bigger one.
the bigger site,
Yeah.
but we went to the outer rim of an impact site, which is incredible.
yeah. So we'll definitely be showing all of that in our video on lots of amazing museums as well. Some incredible museums
We've
they
done a
have
lot
in
of museum
Germany.
visits, haven't we? We've done Oxford, we've done
Yeah.
Cambridge
We did
the other week.
Sedgwick. Oh,
Yeah,
yeah, which is
Cambridge.
Cambridge, yeah.
So that's other stuff. So we recorded a few trips to museums, two trips, plus all the Germany stuff. So they'll be in some future episodes as well. But this is our dedicated talk episode. You've got written here, yeah, what's the next step for us? So we're all planning to do master's
Yes.
degrees after this. Still in the same place in Portsmouth. Just
Don't
yeah,
worry, another year of this.
yeah.
You
So
wanted it or not.
we will still be. We should actually have more time next year, like a
We say
master's
that.
degree. Well, yeah. I mean, we'll end up filling our time with stuff, but it's 1 year. It's an MRes, so Masters of Research. We'll just have one project. We basically another dissertation on anything we want to do with paleontology.
I was going to say, do you want to like blurt out or just say what you want to or area you want to work on for
Yeah,
your masters?
I'll be doing more ichthyosaur stuff. What specifically within that, I have an idea, but it may change, so I won't say what it is. But yeah, we
Copyright it.
I mean, yeah, it's an
Everyone
interesting
listening
idea.
now have just stolen your ideas.
Yeah.
There you go.
That's all right. But I just don't know whether it will stay with that idea. But it's a
It
good idea.
changes constantly. I've spoken
Yeah.
to previous students, and they just say it would change sporadically.
Yeah.
So.
Once it breaks.
But you're moving away from sharks.
Yes, hopefully be getting into plesiosaurs, which I've talked about a few times. But
Yeah.
I've got a meeting tomorrow, so hopefully
Oh, nice.
sort that out.
Yeah, that's very good. And
then
yeah.
I'm traveling down in the world. I'm going to hopefully work on Moroccan crocodiles now. So moving away from British crocodiles to more of the late Cretaceous ones.
And if you're going
hopefully.
to Morocco, you are going to film it.
Yes,
And I'm
yes.
potentially, if there's space,
Yeah,
going to come and film that.
I will take
That'd be
a camera with
amazing.
me. I'll be going with Dr. Nizar Ibrahim. Well, these are just ideas for now, but I put my proposal in. Hopefully, I'll get it back very soon, and we can start the journey.
Yeah, so exciting stuff. And we'll be talking about this in future episodes as well. We just thought, yeah, even though this is the shark special, it is the first Boneheads we've done in a while. So we kind of thought we should explain where we've been. Basically just finishing university and having a bit of a break from everything. But now we're back into YouTube. I don't know when the next Boneheads episode will be because the summer might be quite busy.
We got
We'll go
graduation very soon, so
Yeah, but we'll definitely find some time for it. And then next year, hopefully, we'll be able to do a regular sort of schedule again. So yeah, thank you for all your support. And I've seen some people have been missing Boneheads, which is quite nice. I've had comments asking for the next episode. So that's good to see.
This is all part of a transition to cartilage. This is the next season.
Yeah.
And actually, like sharks, cartilage appeared after, well, bone in a sense.
Oh, so yeah, do you want to talk about that?
Yeah,
because we may as well just move.
in a way, how to make a shark.
Yeah.
How to make a shark cake.
Into the early evolution of sharks.
Obviously, something that's quite interesting is, well, sharks are classed as vertebrates. Got bone. Like, you normally think, is it like vertebrate or not? Because where's the bone? And then what appeared first? Is it the cartilage or the bone? And for a long time, it was assumed that cartilage was the more primitive state before ossifying backbone. Screen. Yeah. But I think in fairly recent years, we've had a few fossils that have sort of shed some light and actually shown the reverse, where bone evolved first, especially in the skull of these early fishes.
Yeah.
Or transitioning to the sort of calcified cartilage you see in modern sharks. And I think one of the first examples we saw of this was a shark called Gogoselachus.
How do you spell that? I'll try and find. Are there any images of it? Go. Oh, there you go. You Google already.
Reminds me of the little go-go's.
Yeah. So.
Oh wow. Lower
wow.
jaw. That's a very low.
Obviously, these fossils have to be because to preserve cartilage, but
yeah.
Actually, what they found is found like bone cells within the backbone. So those were the cells that produced bone, and obviously, well,
Get that up.
Had them, then surely at some point it would have produced bone. Like,
yeah, that does make sense. So they started off with being fish that had bone. I mean, yeah, they evolve. So chondrichthyans are the derived from the other osteichthyon.
Osteichthyons.
Yeah.
Yes, that's right.
Yeah. So
how can you tell what's what?
Labels.
Yeah.
I don't know what these stand for, but yeah, that's
maxilla.
Oh, there we go. Yeah.
It's the skull. Oh, I thought it was like some sort of the body. I was really confused.
Yeah, that is not a nice fossil to deal with.
But I think a better piece of evidence was it was actually a few years ago now, 2020. So another group of cartilaginous fishes that aren't related to chondrichthyons are the placoderms, like Dunkleosteus. And normally we just find like the skull of them or their outer armor because their main vertebral column is also cartilaginous, except a few years ago they discovered a new placoderm, Ingenia from Mongolia,
Oh, it's
and that
brilliant,
actually had bone within the skull and other elements throughout the body. And normally, when it comes to follow the whole, well, it's whatever takes the least
Yeah.
amount of steps.
Oh yeah, here it is. Hang on. So the endochondral bone.
Oh wow, that's incredible.
Yeah. Yeah, you look at this, and I do understand how some people say they do not understand how that is a fossil. There it is.
So,
Yeah.
yeah, and if you're following the path with the least amount of steps, then bone surely would have evolved first before they transitioned cartilage.
Yeah, that's very cool. So I wonder what the kind of like pressure to evolve cartilage
Well,
was.
sharks are a lot heavier than like fishes of similar sizes, especially since they don't have a swim bladder. Instead, they've got that huge liver. I think
Yeah.
they fill about 30% of their body weight, and it's full of low density oils and
Yeah.
fats. Um,
That is how they control their buoyancy.
yes. Although I think some of them do swallow air into the stomach, which helps.
Oh, really? Oh,
Um,
they become balloons.
yeah.
That's cool.
Yeah, cartilage is lighter.
Yeah.
That helps.
Yeah.
It's more flexible.
Mm.
Seeing some sharks, they
I
really
guess.
contort themselves. And
There
you
you
got
go.
like the eel, like ones like the frilled shark. So
Yeah, true. Yeah, I guess there'd be many advantages for it, and I mean, so obviously these. So
probably less costly to produce as well if you're not.
it could be, yeah.
Yeah.
Oh, because I mean, generally with vertebrates as well, we produce cartilage that then turns into bone. That's quite interesting. Then, so are they? Would that be kind of pedomorphic?
Possibly, yeah.
If they're so, that means like
But then again, all evolution is neoteny.
yeah, basically. But so if our bones initially start off when we develop as embryos, start off as cartilage and then turn into bone, they like wouldn't go through with the bone, stay cartilage. I guess yeah, it is interesting. Yeah, I was gonna say as well. So these sharks, we're calling them sharks, but they're not.
Yeah, at
I mean
this
that's
point
not
in
shark,
time, we're
but-
looking at sort of chondrichthyans, which is the whole group of cartilaginous fishes. True sharks appear a lot later, but it's
yes.
quite easy just to go and call them all sharks.
Yeah, because I mean, they do look like sharks, but
Yeah.
yeah, they're not. They aren't quite sharks yet.
Not true.
Sorry, Gogus lacheus was from where? Was it Mongolia?
Australia.
Australia.
The
Okay.
placoderm was.
Placoderm was
Yeah, cartilage is also good because in terms of strength, because it's so flexible, like when it comes to the shark jaw, it allows them to still produce light forces because the muscles aren't actually attached to like a fixed site.
Yeah. Oh, okay.
So they're more elastic.
Yeah, that's true. Oh, and we were looking at that earlier. The
Do you remember the name
What?
of the elastic structure? Oh no, for what allowed them to open their
Oh.
jaws.
So this is a really cool way of showing it. But yeah, basically the jaw is not attached to the skull. You can just kind of unhinge, and you see it in a lot of sharks when they attack. They kind of like go out like that and expose their gums.
They're a bit
Yeah.
like teleosts and a lot of fishes also extend their.
Yeah.
You can really see it in the goblin shark.
Oh yeah.
It's a current tonight.
It is very cool. Shark skulls are insane. We kind of went down this rabbit hole earlier. But
Yeah.
I need to show it again.
Supposed to
Oh, I
start
keep-
recording earlier, and we just kept.
Oh, the hammerhead shark was so
Hammerhead
cool.
shark. Skull. If no one's seen this before, everyone needs to see a hammerhead.
It
I mean,
looks like something from Avatar.
Yeah, look at that thing.
Like you remember that guy in the Pirates of the Caribbean, the hammerhead?
Yeah, the hammerhead. Yeah.
Yeah.
So cool.
They have actually some really small mouths compared to other
Yeah.
sharks.
That's true.
What's the plate in the middle? The mouth.
No, is that just like another grinding surface or something?
Weird.
Clue.
Just forms the bottom of the mouth, or the mouth, I guess. Yeah. Yeah, I love hammerheads. I don't know if we should probably stick to the order of things we're doing, but there will have been hammerhead video.
There's a
this
lot of
week.
advantages to evolving cartilage instead of bone.
Yeah,
A lot of that being the lightness and flexibility of it,
yeah.
which
So
I think helped a lot when true sharks evolved later in the Jurassic. They were hunting faster, agile teleosts.
yeah, like
more
being able
modern
to
fishes.
yeah, and being able to extend their jaws as well always seems like quite a useful adaptation.
Which I will be talking about a less advantaged group later.
Yeah. Yeah, so going back kind of to the beginning of the
Yeah,
story,
'cause
once you get to
Covered this before, but it's nice to go
yeah,
over
so
again.
Catch up, refresher of it.
I rewatched my video. It's just called The Origin of Sharks. I think I did early shark evolution. But yeah, no, I didn't go into as much detail as I probably would nowadays because that was like 5 years video. But yeah, you've done a lot of detailed notes on this sort of thing.
Accident.
So if
Crazy.
we just get I think there's some good like shark evolution timeline things. I know
Although it
what's
has
gonna
been
happen.
pushed back for
Yeah,
the
there
last
was
10 years.
yeah. That's what's gonna come up if
Yeah,
I
every
knew
time
that was
I
gonna happen.
That was so annoying when I was trying to do my research
Yeah.
to come up with a game instead.
The game comes up every time.
You're promoting the
Yeah,
So
game
yeah,
now.
the Natural History Museum website has quite a good
Yeah, that was good.
brief summary.
Michael J. Benton's vertebrate painting. Always
yeah.
good. I love that. It's one of my favorite references.
It is
Um,
saved.
You know
our
what? Fossil
paleontology
Guy
degree.
actually has a pretty good page on Dark Evolution.
What's it called?
I think
Shark Trust.
there's a guy called Fossil Guy.
Is this?
Not that one.
Oh,
No, that one.
this was quite useful.
Dedicated to it.
I mean, there'll be good images. About. So you've got ads on
It all starts a very long time ago, doesn't it?
it. It does.
It
Yeah,
is
about
Zoic.
450 million years ago.
Yes, during the Ordovician. It was a bit earlier than they originally thought. I think some of originally it was thought they'd maybe appeared in the early Silurian, but now it seems that sharks are Grichthians, referring to the sharks, are part of that great Ordovician biodiversification event, which basically spanned the entire time period. Yeah, a lot of them.
Yeah, so we're
Groups
talking
appearing.
about 450 million years ago, the late Ordovician.
Yeah, and yeah, so this is a long, long time ago. But we don't actually find many remains of them back then. We only really find isolated scales, and you know that they're shark scales because they're very characteristic.
Yeah.
They're called placoid scales, and they're actually similar-ish in structure to teeth.
Mm.
Sometimes they're called dermal denticles. So they've got like a pulp cavity and like layers of dentine, and I mean they've got enameloid on the outside, not quite like an enamel, but it's similar in structure.
Yeah. And so that is one of the key characteristics. Sharks and their relatives.
Yes.
We had this conversation yesterday about how they're smooth on one side.
Yeah.
Yeah,
They're
so
rough
if
when you go the other way.
Yeah, that is what they've still got nowadays. I think because I rewatched my video recently, I said that chimeras they start off with placoid scales, but they actually lose them later in life. Grolus, this is a chimera. Ghost fish.
Yeah. They're terrifying.
Yeah, they are
I can't
weird.
stay on that for too long because that is so unsettling.
Yeah. But yeah, if you stroke a shark one way, backwards, because they help with hydrodynamics, nice and smooth, and the other way it's rough because they have the little spines, these placoid scales, which should get it.
They also call
Placoid
the
scale.
material green, and I believe it's
Yeah.
banned in like competitions.
Oh, really?
Yeah.
Yeah, because it actually does like shave off a lot. But yeah, you can
Yeah,
see
here
how
we
like
go.
those
That's
would help with reducing drag because of their sort of V shape,
Yeah, they are really cool.
and that is what you
Crazy
find
that
in
just-
Ordovician.
Yeah, so if you find that, you
Yeah.
you can be pretty sure that's something that's
Shark-like.
related to a shark.
But,
Yeah.
yeah. The oldest named chondrichthyon is Tantalepis gatehousei.
Mm.
I want to say it's Australian. Yeah, and that's just represented by a few scales.
Right.
Yeah, we don't really find any teeth, not until about the Devonian, really. So
Yeah.
it suggests that potentially these early forms were toothless, and that's somewhat backed up by the fact that chimeras, ghostfish, they don't
Yeah.
have like traditional teeth in the sense, like tooth plates, don't they? That
Oh, okay.
sort of continuously growing,
That's interesting.
and there are actually some acanthodians which are on that stem to
Yeah.
sharks that are toothless as well. So potentially early sharks were toothless in some.
Yeah. Oh, that'd be kind of cool. Oh, I mean, that's not helpful for shark evolution. Like studying shark evolution now, because obviously
Yeah.
most of it is based on teeth, the most common fossil. But yeah, that would be interesting. So yeah, so early Devonian. We're in the early.
I've got the
early
Silurian
Devonian now.
first. Or
you're still in the
let's not skip the
Silurian.
Silurian. because it turns out that molecular data suggests that so when we've got chondrichthyans, they first split into chimera group and elasmobranchs, which
Yeah.
are sharks and rays. This split is said to happen about 420 million years ago in the late Silurian. And the first vertebrate teeth actually found are in, well, a shark, a Camphodium. I said earlier that. Oh, I lied. It's Silurian we start finding teeth. But still later than the order.
Yeah.
And it's in a genus called Otodus duplicis. Name.
Yeah, let's see if I can get them.
But it's really cool if you look it up because teeth are in a sort of a whirl, like helicoprion.
Oh, yeah, yeah.
Oh.
Yeah, no.
And those are the oldest vertebrate teeth ever found, beating the record by 40
Oh, is
years.
this the really recent?
Fairly recent.
Oh, I remember this artwork. Yeah.
Yeah, this was like 2022, right? End of last year.
Yeah, so
Yeah,
if you just click off that one,
that one.
well, yeah, that gives you a pretty good idea of it.
Yeah, it is the
their
one I'm
teeth
thinking
look
of.
like.
Yeah, yeah. So there was a whole load of papers that were published all at the same time, describing all of these fossils from China. I remember one of them was a chondrichthyia, not really a shark, but along the lineage leading to them.
Related
Yeah,
to
that's really
sharks.
cool. The tooth wall. Wow.
And it's an Acanthodian, which their taxonomy has been a bit weird, but currently they're
Yeah.
said to be on stem chondrichthyans, like they're on that line. And
Right.
normally they're sort of like small, slender things that look like eely sharks.
This sort
Quite
of
long.
thing.
Yeah.
You look at it and you just don't think a shark. The body, you look at the
Yeah.
head.
Yeah, the
the head
yeah,
screen
the heads
shark.
do
The
look
body just does not.
Yeah, it kind of looks like a frilled shark.
Yeah, but they get their
head.
names from how many spines they've got. If you look at that picture, it's got one on every single fin.
Yeah.
And some early forms, there's one with like 6 along the belly.
Wow.
Oh, really?
Yeah, so they're absolutely covered in them, and that could be to help with predation.
Yeah. Dangerous.
Yeah. They are jaws.
Yeah. The first jaws. Oh,
But,
okay.
no, they were really a diverse group, and
Yeah.
they started out as marine, like deep water predators.
Yeah.
But by the Carboniferous, they move into sort of fresh water, and then they go extinct in the Permian. Last remains are found in Brazil.
Oh, that face. I just saw the screen.
But they've been pretty important for our understanding of that early shark evolution from Devonian. Yeah, but we can now move on to the Devonian.
Oh,
You're all
okay, good. The age of fish. Oh, you wrote that. The age
Yeah,
of
you got
fish.
to.
Devonian. Oh, there we go. That's Cladosalaki.
Yes, Cladosalaki is a very
Yeah.
famous and well-studied shark. Yeah, I think it's found from the Cleveland Shale in Ohio, which is where we get a lot of them.
That's what.
Sharks from. It's a large sand, so it's got exceptional preservation of soft tissue, like the gut remains.
Wow.
Like for example, modern day sharks have a sort of spiral,
Oh yeah.
a digestive system,
Yeah.
and you find that in Cladosalaki.
Ben and I were looking at this the other day, and we were looking at the image on the
Maybe we
left,
couldn't
and
work
we
out
couldn't
which way
figure out
around
which
it
one
was.
was the head.
It must be up here.
It's
where
there
they-
because you can actually see the
yeah.
bottom jaw, but if you go down, you're like, what is going on there?
Hey,
Yeah, it's just the tail has been compressed or something. Yeah. This one makes more sense. I can see it.
Yeah, you can see the
Tail.
tail, you can see the fins, you can see the head, but the other one was just too
Yeah,
funny.
these are amazing fossils.
But actually, the type of teeth you find in Cladosalaki are called Cladodont, which is the sort of
Oh.
ancestral state for shark teeth, which is sort of like
Yeah.
a single
Oh,
point.
okay.
Yeah, like that.
Yeah.
Later shark teeth differ a lot. Like some have serrations and
Yeah.
they are curved or whatever. Or we got some
I
in
was
here.
going to say, is any of the...
Yeah,
Like, wasn't there a really famous one, Scolycorax? They're quite serrated
Yes,
shark
that's
teeth
from
from a
Cretaceous.
bit far from what we're on about.
Yeah, but no, it's a good comparison. Find loads of them. We've got loads at university,
Yeah,
haven't we?
we can find some photographs.
Yeah, but it's a very interesting shark. I mean, I think it's closer related to chimeras rather than true sharks.
Oh, yeah.
But no, it's still very interesting because
Yeah, how is it?
how well preserved it is.
Oh, it's Simoria. I recognize these names. Yeah,
Yes, it's like the one with the anvil or ironing board.
Oh,
for it.
yeah. Oh,
That's
so
what
it's
it's related
saying
to.
that the stem group Holocophalians, so stem group Maras, the ghost.
But it's also interesting. It possessed something called prismatic calcified cartilage in the skull, sort of like overlaying crystals. This cartilage
Yeah.
in the skull,
Wow, look at that.
and that's what modern sharks have, and that's I think that and Doliodus, which is another sort of early, possible acanthodian shark transition form,
Yeah.
which also possesses it. So that feature appears in Devonian. Hamza, you know what else appears in Hyperdons?
Oh, here we go. Yeah, we got.
Yeah,
Like,
because that's when I was looking into some of the earlier hybodonts, which was I can't pronounce his name, Rungodus.
Oh, look at that.
So yeah, this is an area I love collecting hybodont shark fin spines. They're just incredible. Where we normally fossil on the Isle of Wight, they are quite a common fossil. You normally find one, or but when you find two quite close together, you can have a guess and say they're actually from the same animal.
Yeah,
But,
these big dorsal spines here along the back.
And
And yeah, we may as well show your.
yeah, so this isn't actually from the Isle of Wight. This is from Hastings. So that's a near complete shark fin spine. You won't be able to pick it up on the camera, but
Yeah, we can get close up.
get close up. You just show how the size.
There's some massive ones.
Yeah, we have one at uni, literally insane. It's from Carboniferous. It's about that big. About that big.
I mean,
and it's
there's-
only a fragment.
There's a huge one in the Ashes collection.
Yes. There's massive ones in Morocco. But
Yeah, a lot of these early sharks possessed fin spines. Although, yeah, and you don't really find them today. Although Heterodontus, the Port Jackson shark has one.
Oh, it does.
Yeah,
Yeah.
but they're not
there's
related.
a-
So.
Oh, here we go. I love this pair.
what's really
Very
amazing
nice.
about the hybodonts is actually the history. We know quite little actually what the
We're not sure where they
purpose
stemmed
of
from.
their spines are for. We don't know where they probably stemmed from. We know they're sister clades to Neoselacians, which are the modern ray sharks and sharks.
Yeah,
Well, modern
sharks,
rays and
rays,
sharks.
skates.
Yeah. But we don't properly know a lot about their ecology and like when we have like near complete cartilaginous examples. But they're incredible. One thing obviously you love about them is their cephalic spines.
Hmm.
There's examples from Brazil and other parts of the world where they think that the male sharks have these hooklets on their head.
Yeah, you can see it there.
Do they find them? So on the really well preserved specimens,
Hmm.
do they find those cephalic head spines on specimens with claspers as well?
That's I do know, because what was really annoying was trying to find more research on these hybodonts was in the book you had.
Oh, right.
That's gone back to the other
You
university.
should have asked me for it.
I know, but we actually have examples of hybodonts. Like us,
Yeah,
those-
they're absolutely tiny to show on the screen. But I've got a series of hybodont shark fin
That one is quite.
cephalic spines. So it actually shows how big they can get.
Yeah.
But what was incredible, and I actually loved about learning about the hybodonts, was that their cephalic spines on their heads and their spines on their backs, their fin spines, are actually so diagnostic. You can actually tell them to like species levels. They're the most diagnostic feature to the shark.
Well, I mean, if you think of it, if their teeth are diagnostic,
Hmm.
the spines are also derived from dermal denticles.
Yeah.
One you mentioned about the really straight shark teeth earlier.
Yeah.
Hybodonts. There's two groups of. You can split hybodonts even further into two groups. The first group is I need to remember the name. Yeah. So the first group, they have tapering teeth. They have tapering tooth cusps, and they lack any pulp cavities.
Oh,
One of
So if you
these.
go onto the left image.
Yeah.
So these ones actually have pulp cavities, and these are called orthodont teeth.
oh yeah.
And then the
I
ones
remember
that
reading about
don't
this.
have any pulp cavities
Osteodont.
are osteodont teeth.
Yeah.
So those are two good examples of knowing what type of shark you've got, what hybridont you've got, and what group they can belong to. If you don't have the whole shark fin spine, look at the teeth.
On the
Yeah, I
Cambridge
mean,
clay body.
originally wasn't it thought that potentially modern day sharks arose from hybridon?
Mm-hmm.
But one of the differences I remember reading in that book was modern sharks have like triple layer enamel,
Yes.
whereas Hybridons
So,
only got single layer.
Yeah.
I've talked about this in my Ptychodus video. Let me just
Coming
quickly introduce
soon.
Ptychodus. Yeah, hopefully you'll have watched that video. I think it's quite a good one. But it's
Sort of
this is
drill
not
down.
Ptychodus. Every time you Google Ptychodus, a frilled shark comes up. But that is a modern shark. Oh no, he's
Damn
got.
it.
Oh, that's all right. This is Ptychodus. These are the teeth of Ptychodus.
Absolutely incredible. These
Yeah.
you can clearly tell these are gyrophagous animals.
And Ptychodus is from the Cretaceous.
Yeah, that's cutting flesh, mate.
Yeah, but yeah.
Some
So
knives
Can you imagine with
like
a blunt knife trying
Yeah.
to cut some?
I mean, you say that, but some of them are. So obviously these look adapted for crushing hard-shelled prey, and this is how they're
You know
organized.
what?
But then you do
I
have forms
Yeah.
that
Looking at
actually
that
have
jaw,
be able to.
is that a reconstructed jaw? Because
Yeah, we
It
don't
might
have
be.
the.
Yeah, you
we
just
don't have
have
the
these-
articulates.
yeah,
You
because I was
have
going to
these-
say they've made it look exactly like a heterodontid jaw.
Yeah,
I
I
know they
mean they're
said they might
quite
have been
similar. I mean the
related, but
crushing.
Yeah,
Um,
that paleo up there, I absolutely love the one attacking the
This by
ammonites.
Brian Eng. Yeah.
Absolutely incredible.
Yeah, so you can see the teeth here is how they would probably be arranged. They only have some partial skulls and like a few vertebrae, so obviously the rest of the look of the animal is hypothetical.
Yeah, there you go. That's a
and
good example,
yeah, you
Eddie.
can kind of tell the shape that they would be in based on when you have these entire like bottom jaws that are found. Basically, these were for a long time considered to be a type of hybridont. But there was quite a recent paper that looked at the structure of their teeth and found them to have that triple layer structure to the teeth. So there's 3 distinctive layers when you do a cross section of this tooth. And it turns out, yeah, that is a feature of Neoselacians, or the modern crown group of sharks raised in skates. They say Ptychodus is probably not a hybridont. It's going to be a Neoselacian. Yeah, but
Yeah.
that's another example of
Yeah.
that. The
aren't
3-layer
hybridons meant to be
feature.
like slow swimmers?
Oh,
That's what I was reading.
I read otherwise that they were
They're
able to
quite
actually they were
diverse.
they were actually able to catch fast moving
Yeah,
prey.
like they might be able to do first but I read especially when they got restricted to those estuaries.
Yeah, so
freshwater.
that brings me to what I was about to say, was that they actually became so the PTM, which is the Permian Triassic mass extinction, it had affected so much of the marine life, but the hybridons were able to bounce back really quickly. And so after that, they diversified in the Triassic and the early Jurassic until another group arose, their sister clade, which is the Neoselacians. They actually took over. They're the ones that pushed them from the open waters into estuaries and river systems, and that's where we can find them in the Vectis Formation,
Yeah.
all these lagoonal systems. So they thrived in those smaller systems, but sadly towards the end of the Cretaceous.
Yeah.
I just think it's so interesting how they've got that sort of extreme heterodontish, like the cutting teeth, but
Yes.
also the crushing teeth. That's really cool.
Yeah, sadly, towards the end of the Cretaceous, they got pushed out by the new. Well, there's theorized that they got pushed out by the modern sharks and
Yeah, I mean, obviously,
Um,
I would
pushed
have
them over the edge.
They call yeah,
this one.
yeah. Those look exactly like some of the skate teeth I've found.
Oh yeah,
Yeah.
they look like some of the stuff I found as well.
They look exactly like.
Yeah, I swear I found stuff like that in the vectors.
Well, did we not? We were walking in
Otodus.
Oxford, and I found that plate.
Oh yeah, no.
Does that
yeah,
not look really
sort of
similar?
look like that.
Carboniferous.
Did anything important happen then?
Carboniferous.
Yeah, it's actually when sharks were at their most diverse.
Yeah, Gyrophagous forms arose in the Carboniferous.
Oh yeah, golden
they
age
went
of
from like
sharks. Yeah.
they ranged from like really small sizes to like 20 feet,
Yeah.
and yeah, you got
You got
Helicoprion, Stephacanthus.
yeah. So
Really did.
this is what kind of annoys me because these are not sharks. Everyone
No.
always calls them sharks.
Didn't you call them?
I did because when you Google it, it's like, oh, it's a shark, and
Yeah.
I'd always watching
Whoa,
yeah,
it's got
watching
cool hairstyle.
Walking Dinosaurs and stuff. Every bit of paleo media ever calls them sharks
No,
because
they're
that's
close
simple.
related to chimeras, aren't
Yeah, but they are holocephalians.
We
They're just
recently
kind of
saw an
conversion
amazing
sharks.
chimera skull in Sedgwick. It was when you walk in, you turn right. Ben and I were looking at it, and we were like, "Oh, look at this! It looked like a turtle skull." And then you look
Oh,
at it a
that
bit
one,
more,
yeah.
and you're like, "Oh my god, this is a weird chimera."
Yeah, no, it's good because there's actually like a load of Lagerstätter Carboniferous that show these bizarre forms. I think there's
Hmm.
one in Montana and there's one in Scotland.
Oh,
And that's how we know how diverse they were. I think after placoderms went extinct, they really radiated.
so do we know the feeding style of helicoprions?
Apparently, yeah, they've done modeled jaw motion.
That just seems like such a tiresome, energy efficient. Just
Well, they're extinct now, aren't they?
yeah.
Obviously, it
Like,
works
just
for a
someone using
while.
so much energy, just like moving back
It's really
and
cool
forth.
though.
Yeah.
But
Oh
no,
wow, that is amazing.
Wow, that is an amazing fossil.
just funny seeing all the past
Neural
reconstructions where they're trying to work out where in the jaw.
Yeah,
this
I'm
went.
trying to. Oh, here we go. That's brilliant. That's clearly what happened. What do they think that unfurled or something?
I don't know.
Amazing.
It's scary though.
Yeah.
A
Oh yeah,
weird
this
thing.
is it's kind of an older one. So wait, have they found like Durophagus teeth too, or is that hypothetical?
All the
Yeah.
fossils I've seen of it are of the whales.
Yeah.
I want one.
It's
I
kinda
want to
cool
find
see,
one now.
Yeah, going from Otodus from the Silurian, it's like fairly simple tooth whale to
Yeah.
this.
This is more of an up to date. I think. Yeah. Again, this isn't not even a shark. It is a eugenedontid.
Yeah, that's
Yeah.
Epicantthus with the
Thank you.
anvil. Yeah, so all those little spikes on the top, those are those scales, but they've been slightly modified.
Hmm.
So what is the reasoning for having an appendage
Well,
like that? Do we know?
I think, don't you remember in one of our lectures they talked about how might have been an early vertebrate lecture. Where
Yeah.
they talk about how it might have acted like Velcro and
Yeah, because we have
I mean-
is it a type of shark that like they're called Velcro sharks that they stick onto an animal?
There's they think of remoras.
Yeah,
Yeah, it's not a
so like
shark.
they would have sort of
Velcro fish or
stuck onto the females and wrapped their bodies around. Hey, if the
Maybe.
sharks are very flexible, like
Hmm.
it'd be interesting. But yeah,
Okay.
Oh,
Yeah, let's go
Chris.
back to
don't skip it.
it.
It's very important to their evolution. They
Yes.
describe Devonia's golden age of fishes. Well, this is the golden age of sharks because after the Permian, I mean, there's a huge decline. You lose a
You
Camphodius.
mentioned some of the Carboniferous sharks can be found in Scotland. Where in Scotland?
It might be that one actually.
Yeah, I think it is actually. I just remembered.
Oh, no, that's
I did a video on this ages
Oh, that's
ago.
with Montana. Oh,
And hang on. I think I think they have a specimen. I swear there's something to do with Scotland. In
if you
this,
try looking up Scottish Carboniferous shark statum, maybe something will come up. That's not insects.
Possibility of
Scottish-
looking for a old shark video.
I'd
It's
love
It's
to go
a very
back
old
up to
one.
Scotland.
I ain't looking up that one. It's Friday.
There
Maybe I
are-
was thinking of this. Yeah.
there are sharks. But we've got loads
Is
of
it
Carboniferous
Stephacanthus?
rocks. Oh yeah, I think I remember.
Yes. Stephacanthus have been discovered in Scotland. Okay. Is that what you're thinking of?
Yeah.
Nice. Yeah. So we're in the Carboniferous. What else? Because
All I just wrote was the Carboniferous became was an area for Durophagus forms to
There's
literally
just lots of
diversify.
there's loads of bizarre with sharks in that.
yeah, so I love Falcatus. Again, this is Simoria form. So yeah, stem holocopalia.
Sun visor, yeah.
That face.
So yeah, these are amazing. I think again that is just a sexual display feature. I think I did a video on this and called it the unicorn. Not sure.
I think some
people
I've
have
heard,
called it
I've
that.
heard it referred to as
Yeah.
a unicorn shark. I guess so, yeah.
Again, that is probably a display feature. I don't see how that has any functional use.
Well, I mean, it might be like stabbing fish.
But then
Yeah,
why
and
would
then
the
how
other?
does it eat it?
You could say why would the females not have it then as well?
How do you know which one's a female, which ones aren't?
Exactly.
Well, it does say that's a male. So I'm assuming they have a good sample of this.
Thank you, Ben.
Yeah, it's
Well, to be
interesting
fair,
how
are those
much
claspers at the back?
Oh,
then?
that's really interesting.
it looks a lot like one of the hybridont spines.
It really shows how the skull and the spines are the most important, or the part that's going to fossilize so well
Yeah.
compared to
Well, it's because
tipo column's gone.
well,
so
the teeth and the spines are made of the same stuff. So,
Yeah. interesting.
I think we could sort of move on to. I mean, the Permian used to still do get sharks. There is a decline. You get xenocanthus, which I've heard of before,
I've heard of
Yeah.
Xenocanthus.
Yeah.
Yeah.
but they do occasionally find that with claspers.
Doesn't Xenocanthus mean alien shark? Xeno means.
Yeah, it does.
I only remember
It's
that
got-
from
Alien
the Aliens
spine.
movie.
They've got quite an eel-like body.
Look at the skeletal. Oh my gosh.
They have actually found them in some Permian ones. What's that amphibian group called.
Temnospondyle.
Yeah, they do find
Yeah.
temnospondyls in their stomachs.
Oh, really?
In their stomachs. Oh, that is cool. There aren't any images of that, are there? So yeah, this is a Permian. What happened to sharks in the Permian? Was
Well,
there
the same
more
thing that happened to
diversification?
everyone. No,
Oh,
that's
at the end of the Permian. Yeah.
yeah, no.
I
They
can guess what
declined
happened
with
to them then.
Yeah.
Unfortunately.
You can have a
lu-
guess what
luckily
happened
in the
at the end,
Triassic,
Permian.
they
Yeah.
do bounce back a bit. You actually get the appearance of neoselach.
Yeah, so we should probably define.
modern sharks and rays.
Yeah.
And they split in the Triassic.
Neos. I don't know if there is a.
Yeah, because hybridons come under Elasmobranchi.
Yeah.
One of these would have been
Devonian.
closed. I don't know what paper this is from, but
We'll take it for now.
is that even showing?
No, it isn't.
Because I know a lot of them are quite
Phylogeny.
outdated.
Yeah, so
Uh,
Bathoids. That first one. That gives you a better view. Because if you look on the right, it sort of splits into
yeah, I think these are different.
Bathoids, what's highlighted in red, those are your rays, and
Yeah.
everything else is sort of modern sharks.
Was it this year or last year when they said that? Oh no, could be a couple of years ago when they said Megalodon was no longer Carcara.
That was
That's-
a while
it
ago.
It was a
long
while
time
ago.
ago.
Okay, it's now.
Because they moved it
Otodus.
from Carcharodon to Carcharocles, and then to Otodus.
Yeah.
I just love the name so much. Carcara sounds so cool.
I mean, shark done it.
Oh, it just sounds so cool.
Oh, that's quite nice.
Yeah, a lot of these are going to be
Hang on,
competing
look at the picture
hypotheses.
for
Hang on,
Osteichthyes.
Osteichthyes.
Yeah, no, I mean, yeah, that is an
Hang on.
Osteichthyes. We are all.
We're not going down the
Osteichthyes.
rabbit hole.
That was the
We are
first
fish.
episode. You should watch the first episode of Boneheads for further explanation of
Oh,
that.
that's not a good one.
Yeah,
Teeth,
this is quite good actually. Oh yeah. I know this is cartilaginous fishes. There we go.
Really nice.
This just kind of clarifies stuff. So here we are, Neoselachians,
Yeah,
and there's the
Triassic.
hybridons.
Finally.
See the hybridons. There you go.
Normally, like I find the Mesozoic is a bit overlooked in terms of shark evolution. Sort of go, well, they're in the shadow of the marine reptiles, and then they
Yeah.
go extinct. No, but not necessarily because
Yes, in the Cretaceous, they got Neoselachians got very.
well, because as you mentioned, in the early Jurassic, you have the appearance of simian notids and lots of other modern fish like the Ptychodus. Fast moving, like thin scaled fishes that lived in shoals, and sharks were perfectly already adapted for hunting these types of prey, being fast moving, flexible, and that led to a huge radiation of these modern sharks around the sort of pre-Ebonian, like very early Jurassic. That's sort of what shout hybridons. So there is sort of a huge evolution of sharks, Mesozoic, and that's when they also evolved serrated teeth.
Yeah.
And by the mid-Cretaceous, animals like Cretalamna and Cretoxyrhina, which you
I have, yeah.
we were
go
watching
on
that earlier, weren't we?
Yeah.
They start pushing from like near shore feeders to fast offshore hunters. Even in your video, you say like Cretoxyrhina might have been one of
Yeah, so
Ever.
I can't remember. There must have been some paper where I read that it said it could be potentially the fastest shark we ever know of, so far at least. 'Cause they did modeled calculations of its scales and then like compared them to mako sharks.
That's interesting.
Yeah.
do
Well, I
that.
wonder how you do it because
How would you do
you'd
that?
have a cruising speed, but then you assume a similar hunting modern great whites
think
where
so.
it like
It
go
says-
underneath and
Yeah, there's like bursts. Yeah, quite interesting. Oh, I should get. Are we
Yeah, the
talking about?
sharks weren't completely overlooked in the Mesozoic. You do have some that did very well. You looking like that?
There you go. Oh yeah, I love how they call this the Ginsu. I don't get because it looks like the Ginsu knife.
Oh
Ginsu
yeah,
knife.
yeah. We just saw this.
It's just a brand of knife, and they say the teeth kind of look like.
Put it under an electron microscope, but back then they wouldn't have had that. So
Yeah, I'd love to find one of these.
Yeah, those would be. We saw some in the Cedric Museum.
Yeah. And they do find
them.
complete ones, almost complete ones, pretty much.
Yeah, that is really well preserved, isn't it? Because of
Yeah,
of the chalk calcium in it. Calcifies the cartilage. Serves better.
That just reminds me of the hybridon skull they found at Yavland.
Yeah, a little bit. I mean, that was kind of in a big nodule.
No,
block.
the whole thing is the skull.
Yeah, but it's more 3-dimensional.
I would have to find photos later, but
Yeah,
it's a
I can put
really,
those in.
really amazing fossil if you're down the
They
Isle of
find
Wight.
its teeth in like everything, don't they? Like, they hunted marine reptiles even. Well,
Yeah,
vice
so-
versa.
There's some mosasaurs that have it, or at least evidence of it. There's scavenged dinosaurs that must have been washed out to sea. I think that. After that, there we go. And there's the pterosaur, of course,
Oh yeah.
which there is also some cool paleoarts.
Squalocorax. It literally says Squalocorax eats everything. It's just a
Yeah,
scavenger of
scavenger.
everything.
Yes, this paleoart by Mark Whitten that was in this paper where they have an embedded, Cretoxyrhino tooth in a pteranodon neck, which is just a bit insane. That's definitely what happened. Jumped out and killed it just like that.
See, when I first look at that, I can't see what's going on in the Pteranodon. I'm like,
Yeah, it's
wait,
just
Dead.
been
What's going on there?
consumed.
Yeah, no,
It's so cool.
in
Though.
Cretaceous, you have actually got the appearance of pretty much most modern shark groups. Like hexanchiforms are some of the first of Neoseleca,
Yeah, so hexanchiforms, because I did a video on these.
which relates to the number of gills, isn't it?
Yeah, so it's the 6-gill and 7-gill sharks. And I did, it includes the frilge. Yeah. I did a video on this, I think it must have been it was 2 years ago, Shark Week 2 years ago. Because there's a possible record of them, I don't know about the Devonian record, but there's a possible record all the way back to Devonian, which seems a bit doubtful, but there is also a potential record of them in the Jurassic. I think there's like one tooth, I believe. I need to go back and watch that video.
Generally, it would make sense because sharks modern day have 5 to 7 gills, so you'd assume the ones with the most gills appeared first, and they
Yeah,
reduced that number.
this is a very basal grouping, but yeah, they're really cool. I mean, there's 6 gills. I think it's 7-gill sharks. I will check this.
The Megalodon actually had 5 gill slits.
Oh, okay.
They're a
So
lot
they're
less.
more, yeah. But I believe it's the 7-gill sharks that have been recorded hunting in packs.
Oh wow, really?
Yeah, gregariousness is sometimes seen in sharks.
Yeah, I don't know if you'd actually call them proper packs, but like groups.
Mobs.
Yeah. Oh, I cannot spell. Yeah, here we go. Sharks occasionally hunt in packs to take down larger prey using tactics such as stealth to succeed. Which is pretty cool. I think they've seen them attacking dolphins. Or I read somewhere. But yeah, 7-gill sharks are very cool. They do look quite ancient in a way.
Remind me of the Greenland shark.
Oh,
Yeah.
one of the oldest.
Yeah.
Yeah. Yeah, they are very cool.
So
and
sharks do
appeared in
hold
the
a lot of
Jurassic.
records in terms of vertebrates.
Yeah. The oldest.
Well, we were
like,
talking
single
about that
living
earlier.
ones.
We were just talking about it like a second ago about how ichthyosaurs are. Well, you said the longest.
Well, they are one of the longest marine reptile groups in the Mesozoic.
Yeah,
survived.
of course, doesn't count as a reptile, but still, it shows that animals, how long animals can live for.
So if we're in the Mesozoic, I might say some more stuff about Ptychodus, because I've done the video on this recently. So
Ptychodus arrive, like
it's all Cretaceous.
yeah, but when in
Um,
the Cretaceous?
I think when's Niobrara forming? Late? No, it'd be late Cretaceous.
You can find Ptychodus in the UK apparently.
Yeah, so you can find it all over the place. Initially, when they first found them, it was in England, Germany, Alabama, and Kansas.
There was a lot in Sedgwick.
Yes,
Yeah,
there
and
was like
we've
a
got some
whole
cool photos
block of
there.
them. That was incredible.
But yeah, there's. So I counted up the number of species. There's about 27 named species at the moment, and Wikipedia doesn't even list all of them because I found some even more recent ones. But yeah, these teeth. You said they're quite rare in the UK. Apparently, they're quite common in places in.
Yeah,
Can go and
they're
find these
rare
two.
here.
But yeah, it'd be so cool to find like an associated palette like that.
I think it would be cool just to find the tooth.
Yeah, no, any of these would be so cool. But you can see, so some of these, actually, let me look for Ptychodus occidentalis.
You can kind of see how like this shark alone would be responsible for the Mesozoic marine revolution.
Yeah, or like attacking all the hard-shelled prey and
Yeah.
stuff.
Mm.
Yeah, when they first found some of these, they thought they were just fish pellets. And then it was only later they realized they were actually sharks and they gave them the name. I mean, yeah, because you see this.
That's
Maybe
just
that's a
a
fish
big
palate.
Megalodon.
Yeah, pretty much.
Floating sweet corn.
Oh yeah, I love calling it. They look like sweet corn.
Yeah, so some of them are very flat and like clearly for brushing stuff. But then you have Occidentalis. I don't know if that's actually say it, but it's quite a higher crown. They say so. There is a paper. I can't remember how recent it was, but they say that this might have been a more generalist feeder, kind of using this to grasp stuff. Because it has higher crowns, and maybe it wasn't a specialist on hard-shelled prey items, whereas some other species were. There's all this variation.
Well, there's a lot
in
of
the
convergence within
shapes.
sharks themselves.
Yeah. So yeah, it's very interesting. Lots of variation in the teeth. Clearly, these animals were adapting to lots of different environments, which is. And they're also kind of massive. I think.
You were saying the other day
Look
they
at the
got
scale
10
card there.
meters.
Yeah. So some estimates put them at 14.4 meters,
Wow.
which is it might be an overestimate because that is just based on like partial jaws and like a few vertebrae. But there's this one paper. Probably should have got a link to it. They series of vertebrae in Spain. They did some calculations on it, and they found a length for that individual of 7 meters. So quite big for 7-meter shark. You wouldn't necessarily want to be coming across that in the oceans, and you wouldn't want to be a bivalve around it. Like. And another really cool thing from that paper, which I talk about in the video, they actually look at the growth rings of the vertebrae, and they find that it was a slow grower. It got grew very slowly over time. But when it was first born, the first growth ring shows that it was about between like 70 centimeters to a meter in length, which is quite big for a shark baby.
In
Like,
its
come out
first
like that.
year.
Well,
So
especially
it,
since
was, it was born at that size. Yeah.
Wow.
a lot of them give live birth as well. So
Yeah, so that's what they think is that Ptychodus was actually ovoviviparous or fully viviparous, like a lot of some modern sharks. I think actually most modern sharks are viviparous to an extent, whether that is
often,
the eggs
yeah,
hatch inside or whether they have a true placenta, which some sharks do. And they give birth to like fully developed live young instead of laying like egg pieces. So they can tell that Ptychodus was like that. Pretty cool. Just being able to show that from the vertebrae. So
So how long do they normally live for then?
I can't remember if they said that in the paper, but yeah, they are quite slow growing and long
Live
lived
for a
animals.
while, yeah.
Yeah. And yeah, they gave birth to fully developed, massive, meter-long
That is
young.
insane.
Yeah. And yeah, pretty huge. Well, Ptychodus. Look at that, bigger than Cretoxyrhina in some estimate. Wow.
Yeah, well, Cretoxyrhina is probably
Oh,
around
but that's the one
same
depicting
size
as
as
in
modern day
hybrid.
great whites.
Yeah.
isn't it?
So yeah, Ptychodus is really cool. They've given it fine.
Yeah,
stuff.
that's what I'm saying. They're
Oh,
depicting it as a
yeah.
hybridont.
So that's again the older idea, which is that Yeah.
No, it's no longer.
there were some similarities in the anatomy of the teeth to hybridonts, and they thought they were hybridonts themselves. But yeah, more recent work has shown they are probably Neoselacians because they have the 3-layer tooth structure. Apparently, that 3-layer structure is also beneficial to the actual feeding mechanisms because they say it's an unpublished PhD paper, which I think has been turned. Some other authors have made it into like more of a proper paper, but this unpublished PhD paper hasn't been
Published.
and yeah, nothing's really been done with it, which is a shame. Hopefully more will be done. But they show that the structure of the teeth and that 3-layer structure helps stop cracks that form in the outer layer, like going
That's cool.
through the entire tooth.
Yeah.
Because obviously they're using these teeth to like crush really hard substances. Crack forms, and it's one layer could go through it, but these separate layers.
Well, the layers are like have differences in structure. Like what?
Yeah.
Like some are very uniform in crystals, and others are randomly assorted.
I think there is I found a cool figure in a paper showing that. I don't know if it'll come up if I do this. Maybe not. This might show it. Oh no, that's from the paper. Hang on. This is the right paper. I recognize this figure. But this is acid damage. There we go. This is it. So yeah, so this is general selachimorphs
really cool.
showing the dentine, and then that's 2 layers of enameloid that have different structures. I think. Is that what that is?
Well, you got 3 there.
And then this as well. SLE. Yeah, what?
long
Shiny
time.
layered enameloid, parallel bounded. Yeah, but they classify these into 3 different layers. So. Oh no, yeah, it's this stuff. Yeah, okay, dentine and then 3 layers. That's what it is. Yes, and then a single layer. So yeah,
It's
pretty
weird
cool.
why the middle one is different when it's
Or curving
down
around.
the tooth. Yeah. Oh,
Is that just how
no,
it's-
okay. Sorry, yeah, I get the image now.
Yeah, that's just the. But yeah, that's kind of a confusing
tubicles,
figure.
that's
Yeah, I see
why.
that.
I'm looking at it, I'm like, why did it change? But it's tubicles.
Yeah, but that's a really cool way of visualizing. So yeah, Ptychodus has a structure like this and not like this. So more likely to be.
Unless it
Yeah.
somehow randomly got the same structure as modern sharks.
Yeah.
Shows how sad.
Anyway, should we continue with the shark journey?
Yeah, I think
Let's
they
move to
sort of
that.
hit the end Cretaceous,
Yeah.
and they were badly affected by most animals. But suddenly, there's no marine reptiles anymore, and they do pretty well for themselves, especially
Yeah.
with mammals entering the fray. And they make a fantastic food.
Oh yeah. Do we have the big boy? Like, should I get him up?
We have him in front of us as well.
Oh yeah,
Have you seen what I've done to it?
yeah.
Or Otodus. Let's go
Yeah.
with Otodus.
But I mean, if you think about it, it makes sense why sharks became so successful after mammals evolved, because mammals are very rich in fats and oils, what
Yeah.
sharks need for stay buoyant. Yeah, sort of early on, the first winners are sort of Otodus,
Yeah.
and other odontaspids, like sand tiger sharks, which are sort of in front of me here. But
Yeah.
by sort of the late Eocene, they're generally replaced by other lamnids, more modern sharks, like things related to great whites. Like the ancestors of great whites, I think they're 50 odd million ago,
Right.
something like
Okay.
that.
Yeah.
They have a long lineage from sort of what's the term? They're like related to mako sharks, but like wide-toothed ones. That's how
Okay.
they generally form.
Yeah.
Like robust formed
Yeah.
mako sharks.
Yeah, and but Otodus also has a long, going from obliquous Eocene,
Yeah, I
which
think it might
hopefully we'll
be.
find some later. Actually, I've got one here, but they do get
Oh,
huge.
nice.
We've seen some in the museums.
Yeah.
And
Oh, there it is. Obliquous.
yeah, they start off with having those lateral cuspids on the side, the extra
Yeah.
little teeth. As we evolve, they start losing those. Those get reduced and reabsorbed into the main tooth, which becomes larger and more robust.
I think there's a cool figure of that.
Yeah, I think that's
on
one
the
of the
Megalodon.
reasons.
I think we have one in Burnaby as well. We might have
There we
talked about
go.
this.
There we go.
Oh, definitely. Yeah, that's good. But you can kind of see how they thought it might have been related to great whites, because it's
Yeah.
a convergence on that sort of tooth shape, or eating like macro prey.
Mm.
Yeah, so obviously, so I think where we're going later today, they do find auriculatus.
Okay.
Isn't it quite a rare shark?
Yeah, it's gonna be rare. It's mostly stratolamia. That's the most common.
Nothing wrong with a good stratolamia.
Yeah,
I
I know
wanna
you,
find some
you
bigger
like
ones.
them. Yeah, well, I don't know if it will. Well, it might be similar size to your
It's
ones.
generally
finally.
it's
Yeah. Yeah, that'll be cool when we go there. Yeah. Shall we? Oh, yeah, Megalodon. I'm excited for the big boy.
Oh, is it big
Yeah.
anymore? It keeps going down in size.
Megalodon also like increased in size, doesn't it? From when it first appears, like I think during the Neogene.
Increased
and-
really quick,
This
is it not?
Going. Oh no, it's tubutensis.
But like even when it's like it is Megalodon species, as in throughout their
Yeah.
time span, they do increase in size.
And he said that there's a bit of range geographically as well.
Yeah.
Size.
But
And obviously there's the potential nursery sites
well,
too, but I know they've been disputed.
there's Bergman's law. Now they're cited on.
Yeah. That was what that recent. Yeah, I'm remembering now. The
Which we
recent
do
paper.
find in other sharks like Stratolamia, where in colder sort of high latitude areas, animals are larger but grow slower, live longer. But
Yeah.
whereas in lower, in lower latitudes and warm waters, they don't live as long, but they grow faster, and big, and that might explain sort of the size different megalodon
Yeah.
from different localities.
So there's where was the first site that they thought might be a nursery? That was, I know it was
Well-
Central America, South America. Because I know they found another one, I think in the Mediterranean.
Really?
Was it? There was a recent
Yes.
paper, but then they've both been, Panama.
But
I
I
even
think
think of Canary Islands.
I think another species of Otodus does actually have a nursery, and there
Yeah.
are nursery sites for ancestors of a great white.
So cool. There's a place called Bone Valley.
Yeah, so this is the sample of, like mostly juvenile teeth, which is really cool because it is a thing that modern grey whites do.
A lot of sharks have nursery sites, especially those that grow to large sizes. Well, they can't really feed on the same food sources as the adults.
Yeah,
There's a
I think this must be the original paper that proposed it. 2010.
Has anyone done anything on the megalodon remains coming from the North Sea?
no. How
Because they're really rare. They're really, really rare.
might be really rolled if anything.
They're rolled. They're
Yeah, because
really
a lot
rolled.
of the
'Cause they get dredged out the North Sea.
megalodon teeth in the UK are really rolled.
But still, the idea that they're there.
Find great ones in like Florida and stuff.
Yeah, the
Find them
best ones are
underwater.
Florida and but the idea that they're there in the UK is an idea that would be interesting.
Well, very successful. But I think Megalodon is probably another case like the T-Rex where yes, it's very popular, but it's also because it's a very interesting genus as well.
People say it is just a big shark, but
it's not at all.
it's very interesting. We
And-
don't even know for
And
sure
to
what
be
it
frank,
looks like.
it is not still alive. So
Yeah.
there you go.
Also, did not coexist with T-Rex, despite what the Meg 2 will have you believe.
Yeah, the beginning of the trailer of Meg 2 is
I can't wait to watch it.
literally the T-Rex is running towards the water and the Meg just grabs it. And
I think we need
just
to do
drags
a
it to the water.
BoneHeads review of that.
Please no.
What, like the beginning of Walking with Dinosaurs episode 3.
Yeah, it's literally that. It is a recreation of
Yeah.
it, but
Does
worse.
it not catch? Does it not T-Rex go after saying like a Canthostega? It looks like a temnospondyl.
It's some. Yeah,
It goes off to a
something,
temnospondyl and then
but
it
it
goes into a
shouldn't be.
T-Rex and then it goes into the Megalodon.
That's the thing now that it's been moved to genus Otodus. Normally it was reconstructed as just basically a big great white, but
Yeah.
now it could potentially look very different, even if there is a lot of conversions with great whites.
You want to get the model
Oh,
that you just got?
yeah, hang on.
Because I quite like that reconstruction.
Yeah,
it's just
no,
the
it's
PNSO
it's really
model.
chunky. I like
Yeah,
it.
it's got like a really chunky like tail base.
Yeah.
Which it would need to be for an animal that's like 15 plus meters. It would need huge muscles to actually have a caudal tail. Yeah, we've got loads of extra fins.
Yeah. So just comparing it to my great white model, and they are very different. I don't know if you
And
see them in the
teeth,
same
like,
frame.
yeah, the bigger something gets, the more bulky it needs to be.
Yeah. Oh, you know what we can talk about? Turns out Megalodon was not. You know what? Could have been a gigantotherm, or because they've detected signs of it being like properly endothermic, regionally
Oh,
endothermic.
do they find the same sort of
Because I think in the paper they use oxygen isotopes, right, from teeth. There's a very new paper. I talked about it in 70s Science a while
yeah,
ago.
really recent.
Yeah, just a few weeks ago. They find using oxygen isotope analysis. There were two different types of analyses they did, and they basically find evidence from Megalodon teeth that it had an elevated body temperature compared to the environment. What? There goes a bottle. It's alright. Yeah, elevated body temperature compared to the environment around them, but not quite as high as in cetaceans and things, I think. So they are. I'll find that paper if you want to explain it.
I don't remember much about it.
Putting you on the spot.
Sorry, I thought you'd read it. I'll find it. It's very interesting.
But yeah, it makes sense. But that's the thing because
Yeah.
originally wasn't it? Some people thought that maybe the reason they died off was because whales moved to polar regions, but then you do also find them in higher latitudes. So
I thought it was just the extinction of cetopheres and stuff, or like evolution of giant ones. Anyway, this is the paper.
animals would be.
Wait, this is the paper, right? June 26th, yeah. So they test it. Where does it say the isotope stuff?
They use phosphate.
Yes. But yeah, I can't see it, but yeah, I trust you. Something to do with isotopes. Yeah, had a body temperature significantly elevated compared to other sharks, so it had some kind of internal heat production.
Or some of that
yeah.
would be just being chunky.
Yeah, I wonder if they mention. Like, and oh, so
Could at least be.
yeah, so it could be.
Okay, so maybe it
gigantothermy.
might be the temperatures partially, but then they're higher than would be expected of an animal that size.
Yeah. Yeah, so potentially partly gigantothermic, which is just where they get to such a large body size that the rate at which they lose it is
Yeah.
very slowed, so they can still sort of maintain a higher elevated body temperature.
To volume ratio.
Yeah. But they do say in this paper that it's definitely some evidence of at least some endothermy. So warm-bloodedness, what we mean when we say that. But probably okay, because there's no true endothermy in sharks. There's regional endothermy where certain areas of the body are kept warm, and that's because of like countercurrent exchanges.
That's found in a lot of lamnids, like
Yeah.
typical sharks.
It's like great whites have it. Tuna as well. I've talked about this in my video on hammerhead sharks deep diving, which I want to come to that paper in a minute because that's very cool as well. But basically, it's where the warm blood going to a colder area is going one way in a blood vessel, and then another blood vessel is going from the colder area to a warmer area, and they pass each other. Heat exchanges from the warm blood to the colder blood, and the blood coming from the colder area is warmed up a bit as it goes
averaging
like towards
out.
yeah. So it's maintaining a certain maintaining temperature in certain regions, and that's found in other sharks. So that's probably what Megalodon was doing too. So this is a really cool study showing evidence for that.
There's been a lot of really interesting studies on its physiology. Like, recently there was also it occupying a higher trophic level than any other predator.
Yeah, I did a video on that last year, I think. And that's just showing. So there's like an extreme range of what it was feeding on. So a lot of
nose.
Yeah, that's an interesting reconstruction.
Look at the whale.
Yeah,
it's so cursed.
But they do also say that this could explain the extinction of Megalodon, because they're saying obviously that's going to need it to require a lot of energy costs to maintain itself. So once smaller baleen whales that was preying on went extinct, that's a very good source of rich blubber, lots of fats and stuff that they need to maintain themselves.
The smaller great whites, which they are said to be partly due to their extinction, like competition with them, they would require less energy.
Oh yeah, because that was another paper last year. There have been so many Megalodon. There's always a lot of Megalodon papers, but recently there've been really interesting ones.
Very good ones that aren't just size.
Yeah, it's more about their behavior.
Smaller. We want to make it bigger.
I think that would be a good video to do, maybe next year actually. How big was Megalodon? Just go through all of the papers and all the different sizing estimates there have been.
I give it 2 days before they change the size again.
Yeah. If I'm allowed to continue to talk about Megalodon, because I've also been doing a lot of research on Megalodon and Livyatan.
You've been doing it for years now. You've like culminated everything within here.
That's the crazy thing. I was like,
watch out, Kenshu Shimada.
I was thinking that as I was researching this year's Megalodon video, I'm like, I'm actually kind of quite familiar with the Megalodon literature at this point. Because every year I do a video on Megalodon. It's like, oh, what new papers have there been? Oh yeah, I remember this one. That complements this one from this year and stuff. So
when we say a certain date, we expect you to tell us the whole name.
Oh yeah, sure.
The whole reference list.
It's just I end up revising Megalodon every year for Shark Week, essentially. I don't know if anyone even wants more Megalodon videos. I've just forced it to be a tradition that we have a Megalodon video every year because I feel like it.
Keep it going.
Yeah. I'm running. Well, the thing is, I don't know if I am running out of topics for Megalodon because there's always new papers. But yeah.
Give it. Next year you'll have none. You have none. Then you have to repeat stuff again.
I mean, have you even done one on like its evolution from Otodus obliquus to?
Yeah, I did a video on Megatooth evolution, but that wasn't the Megalodon video of the year. Yeah. Anyway, let's go to Megalodon versus Livyatan because I love the thumbnails that come up when you search for this.
Hey, it's got
Ridiculous.
hands.
Yeah, what is this?
Well, that's
Hungry
the
Shark
future
Wiki.
version.
Oh, this is going to be a spoiler for the video because it won't have come out by the time this is out because it's always the last video is Megalodon. But yeah, we're doing Megalodon versus Leviathan, okay, because it's cool and it actually would have happened.
And
As
Ben
ridiculous,
can do whatever he wants.
as ridiculous as some of these images look, I won't be using this one. Don't worry.
Oh.
Use that one.
That's
That's
scary.
always a
Oh, I like.
that's always famous one. The very bottom right
This.
image. That's a famous.
Yeah, this is
Yeah.
Leviathan and Cetus.
Is there any
I
possible
guess.
evidence of them, not like, well, I guess predating on each other?
What Leviathan? Oh, no, basically. All we have of
The big two
Leviathan.
predators in the same area. Let's make.
Yeah,
them
so
fight.
this is what I talk about in the video as well. So Leviathan is very cool.
What cool
I'm
name.
assuming it is pronounced Leviathan, right? Because it's meant to be Leviathan, but Leviathan was occupied by. So-
By Mastodon.
Yeah,
it?
it's
So-
the original name from Mastodon.
I think I stupidly called it Leviathan the other day.
Oh, did you?
Yeah.
Yeah, but then they went with the original Hebrew spelling for Leviathan, which is Leviathan. So this isn't the skull they have. This is a reconstruction of the skull. That's not how nice it looks. This is what it looks like. Trying to
You
find the paper.
described every fossil there. That's not how nice
Yeah.
it actually looks.
Let me find the paper where they name it, because that's just got the best figures for it. It'll be here somewhere.
San Marcos.
All the nature, it's all the news reports, not the actual paper. I hate when Wikipedia
Every,
pages do that. It'll be
reference.
number 1. There we go. Yeah, it's published in Nature, of course. Why? No, we don't need the Wayback Machine. Hang on, because I know what I'm doing. No, I don't know what I'm doing. I
Please.
never know what I'm doing, but I know what I want right now is I want the supplementary material because in the paper they show this is the fossil. They don't have a figure of the actual fossil in the paper. They just have this. It's in the supplementary materials.
It's just like, please, you have to believe
Yeah.
us. We have it. We're not lying.
Because I was like, excuse me, did you just publish a paper of this amazing new skull and not show the actual skull, just a drawing of it? And then I was like, let's look in the supplementary information.
The PowerPoint.
And it's
Oh,
actually,
boy.
yeah, it's actually in here, the actual photos of the skull. So thank you.
Well, nature
for
does
that.
restrict people to like what?
Yeah, I
4
think they have
pages or
figure limits and stuff. But I don't know. I would go with this as a figure
No,
instead.
it's not that grothy,
Oh,
is it?
You could
That's not-
combine it a bit.
Right.
Yeah. Anyway, here's the actual skull. I finally found it. You just had to go to the bottom of the page and access the supplementary information to find it.
Black lines.
I think that's just how they're holding it together.
Oh. Oh, I
Yeah.
thought they were arrows pointing out.
No, it's just been cropped out. It does look kind of weird. So yeah. But yeah, that's nature, I guess.
So is it only the holotype for it?
Yeah. So all that they've really got is this holotype skull found in Peru in 2008, published on in 2010. But they've been finding massive sperm whale teeth like this since I think the 1800s. There were some reports of it. And then they started finding, so they call them the macroraptorial sperm whales, things like Acrophyceta, Brygmophyceta, Zygrophyceta, Albicetus as well, which means, I was telling you yesterday, Albicetus. Hang on. Okay, I'm getting ahead of myself. It's called Leviathan Melville.
You're doing
Melville,
a video
eh?
now, aren't you?
Yeah. After Herman Melville, the author of Moby Dick. Later on, I think after this was named, there's another macroraptorial sperm whale called Albicetus, which is Latin, Greek, for white whale. So also a reference to
Oh.
Moby Dick.
Hmm.
This was named 2015, yeah. So after Leviathan, yeah, very cool. Anyway, I just like that. I just like that there's something called the white whale. It's kind of cool.
Yeah.
Yeah. So this was they were finding massive sperm whale teeth like this for a while, but there's nothing that like large enough for them to explain what these were coming from until they found the holotype skull, which is quite, there's quite a lot there. But this is so far all we have of Leviathan is the skull and teeth from all over the
Yeah.
world. They found some, I think, in South Africa, I believe.
Have they not been found in America as well?
There's a preprint of a paper, or like it was maybe at a conference or something. They've just found potential like massive sperm whale teeth potentially attributable to Leviathan in California. So they are also in the northern hemisphere. Before then, they were only known from the southern hemisphere. But yeah, so going back to a question about evidence for whether they fought each other, there's no direct evidence. It would be cool if hopefully one day they can find some. But basically, it's like this was kind of the authors infer that it's behaving like an orca, going after yeah, maybe, yeah. But because they find a lot of small baleen whales in the formation this was recovered from, lots of cetotheres, like the smaller sized baleen whales. They're like, clearly that's probably what it was feeding on, but also could have been a generalist, kind of going after whatever is in that formation, like seals and turtles and stuff as well. And based on what we know of Megalodon, it's also going after the same things. And you have Megalodon teeth from the same formation that Leviathan is from.
Ooh,
So it's like
okay.
two massive super predators in the same formation. Basically, wherever in the world you find Leviathan teeth, you also find Megalodon teeth. These things were clearly feeding on the same things. There's going to be competition. Surely, this happened.
Disagree.
This definitely would have happened.
Hang on. What's going on with the Megalodon's head? Why is there a spike coming out?
There's also a boat.
Oh, that's
So-
the dorsal fin.
But
Going
yeah,
forwards.
He's groovy.
so yeah, I mean, look at the size of these teeth. That is
Does it
insane.
also like
scale up?
the upper teeth like a modern day sperm?
No, that's a good point. It has teeth in both jaws, so it's different to the modern sperm whale. I don't know if people are aware of the sperm whale skull. I keep hitting the caps lock button. I'm sorry.
You just
Yeah.
got that pumped up on the supplementary
Yeah.
material.
Whale skull.
So no teeth in the upper jaw, only in the lower jaw.
Teeth.
So this, it feeds by like suction feeding and stuff, and mostly on like cephalopods, however you say it. And Leviathan is obviously feeding on something very different, like the other macroraptorial sperm whales. So they say it has more of an orca-like ecology. Yeah. So terrifying creature. Would not have wanted to come across that. Another interesting thing. So I think yesterday you were asking me, where does Leviathan fit in the evolutionary tree? How closely related is it to modern sperm whales?
Mm.
Actually, not that close. So, Physeteroidea is the
What a cool name.
the sperm whale superfamily. This is the modern sperm whale, Physeta, and these are the dwarf and pygmy sperm whales. So cute, I love them. But Leviathan is off by itself, in its own kind of lineage. Albicetus, I think, does actually group with it, but this was published before Albicetus was described.
Hang on. I
Not
thought
sure.
obviously it's
Yeah.
2015. That says 2017.
Oh yeah, it does. Why did it not include Albicetus?
Easy.
That's weird. Anyway, when Albicetus was named, it's not like an actual relationship. It's like a polytomy, so it's not certain, but it's potentially a close relative of it. But yeah, it's not even. The interesting thing is, it's not related to
Oh, that's cool.
modern sperm whales, but it's also not clustering with the other macroraptorial sperm whales. It's like its own distinct
little
lineage.
thing.
Yeah. And there are some differences because I think if you look at Acrophyseta, some of these. Yeah, so Acrophyseta, and I think one of the other ones, the spermaceti organ, where the basin would be, it doesn't go all the way to the end of the skull. So it has this kind of weird effect where there's a protruding snout. Leviathan, though,
Has that.
it does go all the way to the end. The basin extends all the way to the front of the snout, this big bit here that would hold the big spermaceti organ with the oily stuff inside. Yeah, there we go. I mean, that's what it is. All of this stuff.
Chunk.
That is the scientific name for it, yeah. But yeah, it goes all the way to the end, like in modern sperm whales. So that's quite interesting that it doesn't have that kind of snout. I think you see kind of varying reconstructions of the other macroraptorial sperm whales. Some of them do having it going to the end.
I would love to know the bite force of Leviathan.
Yeah. I don't know if anyone's done that.
That'd be
Actually,
cool.
hang on, you reminded
Because we
me.
know the bite force of Megalodon. Well,
Yeah.
it changes rough. It's the same ballpark.
It's strong.
Yeah.
Oh,
The
hang on.
Meg strong.
'Cause I
to
believe-
crush through like bulletproof glass and
I believe they do say, just because nature, you got to get your.
Oh, Carcharocles megalodon. Oh,
Oh, here we go. And to our knowledge, the biggest tetrapod bite ever found. That's how you get published in Nature.
yeah.
We're just digging at nature.
No, I mean, well, it's just funny, the stuff they kind of publish. It's
We're
all
not
the
publishing.
exciting stuff that's gonna get clicks. Yeah. Anyway, can't blame them. I do the same thing.
They also title of this one.
Yeah. What should the title be? I don't know. Cartilage heads, definitely.
Well, we've
Yeah.
moved away from the cartilage heads to
Yeah,
bone
sorry,
heads
hang on.
again.
I just-
They haven't found the rest of the body of Leviathan. It might be chondrichthyan.
That
It may
is
be
true.
cartilaginous.
Yeah, I realize I've just been talking about a whale in a Shark Week special, but I have something to.
But more context for us.
I'm a fan of whales.
Oh no.
I
So
betrayed you this
you're
whole time.
biased, then you would say.
Yeah.
We need a video of Eddie the shark versus Ben the whale.
Just been really running away.
Something dropped.
I can't see.
Your French.
Okay, we're back after a short intermission, revitalized. He's gained a hat.
I didn't even put it there.
It looks good. You need to keep it there now.
Yeah.
We're getting paid for to keep it there.
Well, they give like sharks every single adjective ever.
I don't know if you can see that. There's a shark on my microphone.
They can. I'll go
just in
back
the
in the
corner.
fridge
Ah.
and find it. They can.
Okay.
There's a snippet of you just staring
You're
at the
gonna
shark
get
while it's
notice
staring at you.
Okay. Anyway, we were talking about Leviathan.
No, we weren't.
Oh
No,
no,
we're
we need to
finishing
get off
it.
Leviathan. Basically, Leviathan, Megalodon, both. Oh wait, slight tangent. But there was this paper I was reading about where they found this big. They took a big sample of a bunch of smaller orca-sized macroraptorial sperm whales from towards the end of Megalodon and Leviathans when they were alive in North Carolina, I believe. They did cross sections.
Cross sections for the teeth.
Yeah, did cross sections through the teeth. I forgot the word for some reason. And found that weirdly, even though they're orca-sized and had an orca-like ecology, they were only living till about 25 years old. Not many were getting past age 20.
Yeah.
So turns out they were actually modern sperm whales and modern orcas live till like 65 years plus. Generally.
Faster, yeah.
Yeah, literally. They so these back in the oceans when Leviathan and Megalodon were around, orca-sized sperm whales that lived like orcas, they were not the top predators. Even though orcas are top predators now, back then there was an extra link in the food web
Yeah.
of even larger super predators, Megalodon and Leviathan, potentially other things as well that we don't know about yet, like other species of Leviathan. I wouldn't be
Yeah.
surprised if they found more species or more giant macroraptorial sperm whales. But they were putting this predation pressure on these smaller orca-sized ones and forcing them to have to grow really quickly, mature really quickly, and then die quite young. And it's only since the extinction of things like Megalodon and Leviathan that whales have been actually able to
Technically,
live longer.
Yeah, Megalodon still having an effect to our modern day world.
Mm.
I mean, well, yeah, I get in the sense that like we've got great whites around nowadays because
Yeah.
in your like extinction video you talk about like there was like a fairly large die-off of sharks around the same time as
Yeah.
Megalodon, isn't there?
I mean, they've made it through so many mass extinction
Yeah.
events at this point, but yeah.
There's not, yeah, because a lot of people say like, oh, they haven't really changed much, but it's just due to their diversity. That's how they've been around for so long. Like,
Yeah.
there's all these bizarre, weird, different forms, and it's due to their diversity that they've managed to stick out with one set of adaptations, being
Pretty
able to
much.
make it through.
Yeah. And I mean, they are very adaptable, and
Yeah.
that does quite nicely lead me on to the last thing I wanted to talk about, which is the other video I've done for Shark Week, and then after that we can move on to your stuff again. This paper, so kind of a not the best segue, but Megalodon going to hammerhead sharks again. This paper is incredible. Came out when was this? May of this year. Turns out hammerhead sharks actually hold their breath to dive even deeper underwater. which
do
kind
that.
of just blew it blew my mind when I read that. I was like, what do they mean they're holding their breath?
Yeah.
Because obviously they're not going to the surface to breathe air. They're fish that, they've got gills to extract oxygen from the water. So what do they mean by this? Well, they explain very nicely how, most fishes are ectothermic, so cold-blooded, that's what that means. The body temperature is regulated by their environment. But yeah, gills are very good at exchanging oxygen with the water, but that also means, because of all the blood flow and how thin it is and exchanging stuff, they lose heat energy very quickly to the water through the gills specifically. So hammerhead sharks, and they're talking about scalloped hammerhead sharks in this paper.
I got a picture of one.
They should do. They've got this great figure here. It goes, meow. Yeah, let me find a scall. Oh, I know how to spell it. Hammerhead. So these guys are generally shallow, warm water inhabitants. But it turns out the food they go after, so like many kinds of fish and squid, live in deeper waters. So they have to go down into deeper, colder waters to hunt. And that's a bit of a mystery because doing that would mean that they lose a lot of heat very, very quickly as they dive down because they rapidly lose this heat through their gills. So what are they doing here? Well, this paper, the scientists put a load of logging devices on a sample of individuals, and they recorded, I think they said, over 100 separate dives. And these logging devices, they record the body temperature of the shark, like its activity, its orientation in the water, and the ambient water temperature. And what they find, so these graphs are there's a lot going on in these graphs, but basically the main thing to look at is the depth along this axis and the body temperature of the shark along this axis. And it shows, so these are the dives. So it starts in shallow water, under 200 meters, under 100 meters, goes down all the way up to 800 meters. They've also been recorded diving deeper than 1,000 meters, so they are quite deep divers. And then going back up again to under 100 meters. And the body temperature, this is really interesting because obviously it's being maintained here, and then it starts going down, and you'd expect this is like rapidly becoming very, very cold waters, like around temperatures of like 5 degrees Celsius, going from like 26 degrees Celsius waters to 5 degrees Celsius. That is quite a jump. But the body temperature, it maintains itself really nicely until the ascent phase. So they come back up, and then the body temperature drops and then starts warming again. So how are they doing this? Because this is where you'd expect the body temperature to drop really rapidly as they go down into the colder waters. Well, it turns out what they say is whatever is happening here, it cannot be it can't be that normal functioning of the gills is continuing, because that would mean that the body temperature would drop, and obviously that's not happening. So they're doing something to their gills to stop it happening. There's no evidence of regional endothermy in hammerhead sharks, so it's nothing to do with that. So what they think is happening is that they literally just close their gill slits, physically like close off their gills, so that they can no longer breathe. They can't exchange oxygen with water, but they're also not losing heat rapidly through the gills. So it turns out that, like, you done with it? Can't see the amazing graphs. Yeah. It turns out that, like in diving marine mammals that have to go up for air, and it's the oxygen that's limiting their dive length. That's also what's happening in some fish, such as the scalloped hammerhead. I think this might be happening in other fish as well that deep dive and aren't regionally endothermic, but there's no direct evidence of it yet. There's also no direct evidence of this happening.
Do you think the decrease in body temperature as they're ascending is when they open their
that's
gills
when
again?
they open again to start breathing, so they rapidly lose the heat as they're in cold waters, but it's not as rapid as this, and they can warm up again. That's probably what's going on. So it's just this, really interesting paper.
Complex way as well.
Yeah.
Really complex.
And somewhere in the supplementary information they provide. No, I've been looking through all of these. Please. No. It's an. I should have prepared this before. Basically, there is video footage, ROV footage of. let's see. This is how you do science. It's just following links to different papers, basically, of a
We
really
go
deep,
nowhere.
yeah, scalloped hammerhead shark, deeper than 1,000 meters down. Okay, so now, oh, Charlie, can you take this off screen? We're gonna have to log in. Is it gone?
No, everyone can use it now. Right. Maybe a pound
Something
every
went
time you use
wrong.
it.
Hang on, keep this off. So there's some footage basically of this is very annoying. Why is it not letting me see it? Supplementary materials. I'm dumb. Here it is. It's a video. It's a video of a shark really deep down. And it's really cool. This is not the video.
Oh.
Unless it becomes the video I'm thinking of. Oh, that's so scary. That's so scary. This isn't the video I'm thinking of. There's another video. But
That's definitely gonna give some.
Yeah.
What's that called when people have fear of?
Thalassophobia. Or
Yeah,
something.
that's.
I think
Anyone's got
I think I
thalassophobia.
have it.
Fear of
slightly.
the unknown in the ocean.
As much as I love, yeah, Charlie can show this.
Oh, warning.
Yeah,
Mhm.
as much as I love marine animals, yeah, footage like this. The other footage I've seen is not as scary. There's something creepy about this. But yeah, this is a really deep hammerhead shark, and it's not the footage I'm thinking of. There's another footage where you can see the deep diving hammerhead shark has its gill slits closed.
Oh,
You know what? I'll put it in post. I'll put that video
wanna
in.
find it.
Remember to
That's
do
a
that.
really cool bit of ecology.
Yeah. So yeah, it's this ROV that's over 1,000 meters down, and it's filming this hammerhead shark, kind of like this, but it's better footage, and you can
Is that
see
something
that.
like all hammerheads do, or?
I was
Well,
just thinking,
that's
this
the-
could we see it in fossil evidence? But that's
Nah.
really unlikely.
Yeah.
You would
that,
have to find a really complex structure in their head that would do the same thing to the body,
I don't know how
and
you
then
can do
relate
that.
that back to fossil evidences.
We don't have a figure of that. It's annoying. But yeah, basically they say, you know, is this happening in other fish? They want to investigate that further. They also want to attach cameras to the pectoral fins of hammerhead sharks to see if they can actually film the gill slits closing as they dive, which would be really cool. But yeah, just really interesting, kind of surprising adaptation of these animals, showing that sharks are still out there throwing up surprises all the time. We are quite
knows
far
where
from
they'll go in the
understanding
future.
everything. Yeah. So yeah, I just randomly came across that paper one day earlier, like a few months ago. I was like, this needs to be a Shark Week video. This is so interesting. So yeah, that's what I wanted to say about it. Shall we? Oh, so you wanted to
Wanted to
talk
Oh.
about?
well, I want to talk about why sharks are important to paleontology.
Yeah.
Something I found out in my dissertation.
Fuck.
Because I mean, a lot of the stuff we've mentioned today, like their long existence
Yeah.
and their evolution, makes them actually really important fossils for paleontology. Because while we don't generally find their skeletons, their teeth are so abundant. Like, we've got boxes of them here. And
Yeah.
we'll be going out later and we'll hopefully find loads. And
I
that's
hope
due
so.
to how durable their teeth are, and they're really easily fossilized, and you find them so often. So having a record like that, stretching back to the Ordovician, is invaluable for our understanding of evolution, because not only does it reflect like this very important vertebrate group, but it also reflects the pressures put on them by other animals around, like
Yeah.
Could you
different
say
factors
that?
in terms of environmental.
Could you say that if you're looking at an abundance data, they can be like biozonal fossils?
I've not really seen them used as biozonal, but you potentially could use them as biozonal
Like
fossils.
you could have one section of the stratigraphy that has a high amount of stratolamina, then it gets lower, 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 then high again. So
Potentially, but because you do find them in abundance, you can use them for like statistics and even as environmental proxies.
Yeah.
There was that, I think you covered it in 7 Days of Science, a stratolamia paper where they have huge samples of it and look at the isotope data.
yeah, I saw a
And
paper on
you can figure out
about that.
salinity,
Yeah. That's really cool.
temperature, all kinds of stuff, because they're found in a range of environments that some species are restricted to. So you can quite easily determine like different conditions they lived in.
Yeah. Yeah. Because we generally, whenever you think of shark fossils, it's like, oh, they're not that good. They're just teeth because
They're pretty.
they don't fossilize that
teeth.
well.
The
But
teeth are
but
great
they are-
fossils.
they are some of the most important
Yeah.
parts of the body that actually do
Well,
fossilize. So
Now, I remember reading like there was a study done, and I think tiger sharks lose like one a day.
Really?
Oh wow.
Yeah, so
Yeah, so it is just like a continuous and super abundant,
yeah.
like like data records just going back that far.
And they can also tell us like what they were eating and
Yeah,
kind of stuff about their ecology. So I think they're really important sort of group for paleontology.
yeah, absolutely. And with things like Ptychodus, where they have such variable teeth as well, and yeah, that's like directly reflecting their ecology, what they're feeding on, and you can track their evolution. People have tried to do that with Ptychodus. It's complicated because we don't really know what sort of shark they are, but yeah, you can see how they
I
evolve
can
over
imagine
time.
that's why there's so many species, because the patternings are so different on each.
Yeah,
spawn.
exactly. They're super complex
But,
structures.
I mean, that's the thing, and it's also important for understanding modern sharks, like where these adaptations have come today, where they stem from. But also, when I was reading the handbook on Rickfians,
Yeah.
it talks about how paleontologists, so we're restricted to teeth mostly. That means biologists mostly focus on the soft tissue. When it comes
Yeah.
to detailing teeth and classifying them, we're actually the best at it.
Yeah, that's true.
Paleontologists have done the most work on shark teeth than any other
Yeah,
biologist.
that's all you got, mostly. Yeah, no, that's really cool. So that sort of leads you to what you did for your dissertation. Which
Yeah, so
I'll talk
I
about that.
covered generally looking at paleoecology of sharks from the Eocene, so about 55 million years ago, in a couple of localities, and I mean we done a video on it about a year ago now.
Yeah, make sure you go and watch. I think it was called When Sharks Swam Over London, I think I called it.
So
And
do
that
you have
was your-
figures? Do you have your photos?
Oh,
have
yeah, do you wanna
photo
find your-
figures, or...
Dissertation.
Yeah, I think I've got it on there somewhere.
Okay.
Yeah, so the first locality we went to, which we visited, was Abbeywood in London. So if you see the red marker there,
There it is. It's kind of crazy that it's literally just
Yeah.
in the middle of London. There's this amazing fossil site. Yeah.
the images are better in real life. This is just
Yeah, yeah.
The quality of Eddie's
Shut up. But the other one I went to was Walton and Livyatan, which
Yeah, is
you
that?
can technically find Megalodon teeth there.
is
I
this-
didn't, but
There's Abbey Wood.
yeah, that's from the BGS.
Yeah. This is Abbey Wood. Oh, there we go.
I don't know why it's come out like this, but
The
anyway,
nays.
yeah,
Don't worry, my dissertation did the same.
yeah. So the yellow line indicated where I went in between.
Yeah.
If you go a little bit further up, yeah, there's
This.
Miocene junction bed where you can find whale bones and
Oh, really?
Yeah.
that's where you get the Megalodon teeth from.
Wow, that's cool. So
Yeah, although I
That's
didn't get any of them,
sustainable.
I wasn't. Well, I am interested in them, but that's not
Yeah.
what I was looking for.
no.
And that sort of shows you what the world looked like at the time. It was sea levels were higher than they are today.
Yeah.
I was able to find them on land.
You
And
wanna?
yeah, actually around this time in the London Clay Formation, you had another sort of thermal maximum. Where so things were already really hot, a bit of a hothouse environment. Like England was like the Amazon. And the famous one people know about is the Paleocene, Eocene thermal maximum.
Yeah.
Where temperatures went up, but there's a few and generally during the Eocene temperatures start then declining, but you have inflections and it starts bouncing around. And Walton and Livyatan is an example of a formation during one of those rises in temperature.
That's cool. Yeah, definitely an important point in history then. So do you want this?
Yeah. So and I mean I found like 400 shark teeth overall.
Yeah.
Yeah. Here's I believe that is Anomatodon shepiensis. That's related to modern day goblin sharks.
Oh, cool.
Yeah. I don't know how much it would have looked like.
Yeah.
Yeah. If we just go through some of the teeth I found, these are some of the better specimens. The Walton and Livyatan ones are a bit rolled.
Oh,
Not
so
as
good.
great.
So we'll hopefully be finding some Stratolamia later today.
Not Macrota, though.
It's said
it should be
Macrota.
Macrota.
Yeah.
Yeah, Striata is the Paleocene species, and then it evolves into Macrota, which is generally larger. And that's what I was finding. Like, yeah, that was a big tooth. That was like close to 3 centimeters. Some more Stratolamia. That was definitely the most common I found. Like,
Yeah.
most of my teeth did belong to it. Very much dominated its environment. I mean, it's a sand tiger shark here. It was very what's the word?
Common.
I was gonna say sort of like adaptable to different environments.
Oh, okay.
Yeah.
Oh yeah, that's
That's
a
really
SEM
cool.
image I made.
Yeah.
Stratolamia.
Very nice. Is this one of the side teeth? One
Yeah,
of your
so
lateral?
sharks have like The teeth aren't all the same. The ones that are
Yeah.
front are normally pointed and straight, whereas back can be curved.
I
Yeah.
was gonna say point
Cool.
out on the suit which tooth it's gonna be.
Well, they're all the same, aren't they?
So is that the pulp cavity though? That the
Where?
On the
the
other one.
SEM image where it's
No.
all mottly.
No, no.
That's just the
That's just
root.
is that
that's the root,
matrix?
and yeah, be a bit of brains on it.
Okay.
This is a different.
Yeah.
genus.
That's Brachycarcharis, which is also a fairly common Eocene species. A lot of
Mm.
them all belong to Odontaspids.
Yeah.
You do still find the genus today, which is sand tiger shark. Lives in mostly deep waters nowadays, but these were mostly like shallow water predators.
Yeah.
Living in fairly warm waters.
So this is that more? Oh yeah, more.
Yeah,
Oh, it's a
more-
different species.
Yeah, it's Brachycarcharis, but because I was finding some of them crossing over in different localities,
Yeah.
different figures.
Very nice.
Silvestri lamia was also a fairly common one. Yeah, it's actually really similar to Stratolamia in terms of how it looks, but there's a few slight differences. Like often
Yeah.
it's a little bit more curved, a bit straighter in side profile.
Was that a different
Yeah,
species?
that is still Stratolamia. Just that one would be
Yeah.
from Abbey Wood. That one's from Ace. So there was some crossover in species. I think the three species that crossed over were Stratolamia, Brachycarcharis, and Silvestri lamia. All the rest
Okay.
were
Unique to each
unique
one.
to the varieties. So that was a fairly large
Wow.
one. That's Otodus.
That's
It's
nice.
not great, but it was so.
Go
I mean,
on,
as
yeah.
the species name suggests, it's very robust compared to
Yeah.
the teeth I was finding.
And you got Sphirolamna.
So it's somewhat similar to some of the other lamnids. This was the only lamnid shark I believe I found.
Oh really?
Yeah.
Oh.
Yeah. This.
Is it just not suited to that environment?
Well, at that point in the early Eocene, the Odontaspids were dominating.
Yeah.
And I mean, there were some lamnids around. See, but and that's the thing. I only found a lamnid in Walter slightly younger than Abbey Wood,
Oh okay.
but by the later Eocene, the
Yeah.
lamnids start replacing.
That's cool. So you can
Odontaspids.
sort of
Yeah.
see the start of the faunal turnover in a way. Very nice
The
SEM.
next one, really interesting. So it's not a very good tooth, but it's completely different from anything else I saw,
Yeah.
and it's actually one of these. It's a fresh
Oh,
shark.
that's cool.
Huh.
I love
Yeah.
this.
And because of its really long tail, when I was working out the size of a tooth, now, fortunately, because that's a lateral, like towards the back of the jaw, it's less
Yeah.
reliable.
Hmm.
But I'm estimated that one for a 6-meter shark.
Wow.
But yeah, it's a bit tricky with that one. 'Cause it's
Yeah.
a bit anomalous compared to what the rest of everything else I was finding there.
That's very
But,
nice.
so it was quite interesting to find some extant sharks, but also some extinct stuff.
Yeah, you
You
got a
had
nice
sort of that
mix.
crossover, which
Yeah.
you don't find so much in older
Interesting.
strata, but with Cenozoic. Interesting to see that.
Yeah.
And that's those are some Heterodontus, like Port Jackson.
Yeah.
shark.
Yeah. You can tell. Kind of more for crushing a little bit. It looks like.
I couldn't those teeth were absolutely tiny. I couldn't
Oh
really
really?
identify them
What's
until I
the-
put them under.
Oh,
the
yeah,
SEM.
1
scale,
millimeter.
1 millimeter.
And I think
Wow.
actually,
Oh my god. Yeah. Oh, they're still on the SEM plates. That's cool.
still
Yeah, that's cool. Oh wow. Yeah, they are tiny.
yeah. So it's kind of hard to identify them
Yeah.
without putting them under the SEM.
Yes, I don't know if I don't know if that will pick up, but basically they're
Right.
mounted on these tiny circular plates that you put in the SEM scanning electron microscope.
I mean, that's
They get these really nice
that's the
images.
thing. Like the most of the teeth I was finding were tiny. I was using sieves and a lot of acid to
Yeah.
uh,
Oh yeah,
give them
I
out
remember.
the
I think I got
sets.
footage of that
yeah.
of you doing it. Oh, that's cool. That's
Yeah, so these are skate teeth. So
Yeah.
that-
I remember finding one of these when I went
And-
with you.
that's those are really cool, and that sort of helped me identify sort of the environment and
Yeah.
general ecology of sharks from Abbey Wood, because I didn't really find any Durophagus feeders from Walter Monets, but I did Abbey Wood, and generally Durophagus feeders are found in very, very shallow waters like estuaries and
Yeah.
like less than 100 meters, maybe really, really shallow water,
That was
living
really
along
cool.
the bottom of the seafloor.
Did you want this?
Yeah, you can show
Yeah,
that. So that's all
that's
shows the
cool.
diversity I was finding, and you can see. So orange is Stratalamium macrota. You
Oh
can see
yeah.
how it sort of dominates. But what's really interesting, even though like yes, there is a lot of skew towards one species, Walton was more diverse, like in
Yeah,
comparison to Abbey Wood. And
that's cool.
yeah, so I potentially related that to maybe a greater depth where you had more pelagic species that lived in open water. Maze,
You want these graphs?
uh,
Very nice plots you got there.
yeah, go on. Yeah, so that's just showing that because I had a range of size of teeth, that even though like yeah, there's a good range, they weren't like random in their
Yeah,
size increase, and so that meant I could use them to estimate size
that's
of the
really cool.
shark because they would linearly scale,
Yeah,
and that's just generally showing the distribution of body length
nice.
sharks.
Is that?
I
Yeah.
don't want to zoom.
Oh yeah.
Yeah, no, there's some interesting graphs made.
Oh, you got.
That's the figure I like. If you skip to this one, yeah. So that's all. So this is for Stratalamium Cotta. That all shows you the size ranges I was finding. So the black is the maximum and minimum I was finding. So I was finding, especially at Abbey Wood, I was finding lots of really tiny Stratalamia. Like overall, yeah, sharks generally were smaller from Abbey Wood, which you would find in a very shallow
Yeah.
estuarine environment. But especially for this species, generally the size estimates were within the like sort of baby length of what's it called? Sand tiger sharks today, like less
Right.
than 90 centimeters.
Yeah.
And you can sort of see so the red is well, the red and blue is the average sizes between the two localities. So red is Walton on Lees, blue is Abbey Wood, and you can sort of see there's a fairly large size difference between the two.
Yeah.
But with huge range. And so I sort of came to the conclusion that Abbey Wood, yeah, it's some of the species that are very much demersal, like living on seafloor species, very small, and a lot of them could tolerate freshwater brackish conditions.
Yeah.
Yeah, relating back to that estuary. But also, I potentially hypothesized that it might have been a nursery site for Gratalamia. Because it is seen with sand tigers today, lots of sharks have nursery sites, and I did do some statistics between two sites and found there was a significant difference between the body size. So it wasn't just general variation in body size. So, and considering how small they were, and even though I had an abundance of silvestrian lamia, which, yeah, was smaller than the Waterman specimens, I felt like that was kind of expected from a shallower environment.
Yeah, it's really
and
interesting.
it wasn't as the difference wasn't as great with.
Yeah. Yeah, because I remember you discussing that with me when you were working on it. Yeah, it definitely makes sense, especially if it's some like a behavior you see in modern equivalents and based on the environment that the Abbey Wood deposits represent. It definitely makes sense. So it's really cool that you have like the statistical evidence for that as well.
I mean, I imagine someone might be able to go, oh well, maybe not, but I felt like
Yeah.
the evidence pointed towards a potential nursery site.
Yeah, you kind of you didn't outright say that in the you were like, this is what the evidence shows. And it's pretty it's compelling evidence. So
yeah,
it's very cool.
It was really cool finding like just a huge range of species. You can sort of like build up the environment in your head, like when you've got all these different species. And I wasn't just finding shark teeth; I was finding bits of fish, bits of birds, some mammals.
Nice.
No, reptiles.
Yeah.
Same thing.
And not they are fish. Everything's fish.
Yeah. Yeah. So it was cool. Oh, do you want to show me
a reference list?
Depth chart?
Yeah. Is that?
Yeah.
Or...
So that's Abbey Wood, and you can sort of see how they all sort of fall into that range of like less than 200 meters. The only outlier is for fresher, but considering if you look at the geology of Abbey Wood, it's a high energy environment.
Could have been washed in from further out.
Easily. Well, you get lots of mammal remains. Shouldn't
be
there.
Yeah, that's pretty cool.
So definitely easy could have been.
And then
whereas if you put Walton on the knees,
much deeper.
It gets a lot deeper.
What's with the gap at the front?
They're just not found in shallower waters.
Yeah.
Okay.
So that relates to it. Although, obviously, there is some leeway with this because you're looking at extinct taxa, and some of them don't have as close relatives as you like, or like, for example, Odontaspis winkleri. It lives in deep waters, but all extinct taxa are shallow water. So trying to estimate the range is different. Like they might have different ecologies, even if they're closely related. Something you have to look out for.
Yeah, that's amazing. And you got a very good grade for it as well.
Yeah.
Had our results back now, so
Yeah.
yeah.
So yeah, it was really fun doing that, and yeah, so it shows you that sharks can be used to work out the sort of environment of localities, and yeah, it's really interesting to look at ecology and how.
Yeah, it was cool that you used like actual like statistics for
Yeah.
a big data set and everything. I want to do stuff like that, but with the project I was doing, that wouldn't really. It's not really applicable. Yeah, I'd have to have a big sample. I was just working on one specimen. It's like you're doing the proper science, you know, not just describing a skeleton. You're doing actual data.
Just threw numbers
stuff.
together.
Yeah, but it's really interesting. It's
Yeah.
really cool. Maybe you'll get it published one day.
Dunno.
This is basically it being published, right? Talking about it, loads of
Yeah, I
people.
guess. But we'll see
Yeah.
how many people agree.
Yeah.
Is it a nursery site?
Leave a comment below. Do you think it was a nursery site? Abbey Wood. Yeah.
So.
Abbey Wood site.
Yeah, but
Nursery
no,
site. Yeah.
But yeah, can't leave out Waterman. It's a very interesting environment.
Yeah.
Because I believe it was part of a transgression. No, I mean, it was a regression or transgression. I can't remember.
Transgressions when it gets deeper, like goes over the
Regiment
land.
is going out.
Yeah, I believe it was part of a transgression.
Yeah, that's very cool. Yeah, so I think we'll now do our segment on the fossils we have. We're gonna kind of do that after we finished recording, so we can move the cameras about. So we've got a bunch of fossils laid out here. Let's take a look at those. Okay, now switch to this segment. We are minus Eddie now, unfortunately. We're actually recording this a few weeks after we recorded the rest of the shark episode. Turns out we didn't have time. We were going off to fossil hunt, which you'll be sure to catch that episode tomorrow when that comes out. So we're back home in our paleo house. Yeah, and we're going to show just a few of the fossils that you brought along to the episode. So we've got some nice hybridont fossils here. So got another camera set up, and we're going to kind of switch between them. So yeah, we'll start showing these fossils here. We've got lots of hybridonts here, hybridont shark relatives. The classification is a bit.
It's all over the place.
Yeah, I think it's been debated quite a bit in the past, but they're not true sharks. They're not like actually Neoselacians, but they are relatives of sharks and obviously very prominent during the Mesozoic.
Which they would have picked up in the video. So I remember going through that. I remember
we did mention them.
But I think from the Isle of Wight, so these are from the Vectis Formation.
Yeah.
They're about 125 million years old. They're from like a lagoonal setting, from a group in the Vectis called the Shepherd's Chine member. And you can tell it's a Shepherd's Chine member because of these shelly limestone beds. But we're not here for that. You see these amazing black fossils in the middle. These are the shark fin spines. So the shark will have a... Let's see if I can grab one from actually behind. Yeah, I'll grab you.
Yeah, the props.
So the shark will have its fin. It's got its dorsal fin and then it's got its caudal fin. Then the shark will also have another bit of bone. Actually, it will have a bit of bone in front of the fin. Now that's called the shark fin spine. So the spine will go in front of the shark like that.
That's a good way of showing it, actually. Can you?
Yeah.
Yeah, that actually matches up. That's good.
It's not probably in focus, but the shark will have its fin like that.
Yeah.
And then it'll have one behind, a smaller one. So there's an idea, we don't fully know what these are for. There's an idea that they're for active defense. So if an animal comes from above, tries to bite it, it will hit the spine.
Yeah, most likely is defense,
Yeah.
based on like the position and everything. But they make very nice fossils and they preserve very well. Obviously,
Yes.
as we talked about in the rest of the video, sharks having cartilaginous skeletons, meaning generally they don't preserve too well. But the hard parts do, so you get the teeth and the
so
spines.
You get some of
And
the
so,
teeth, so hopefully this focuses.
yeah, it's focusing
Here's
well,
one of the
actually.
teeth. It's not the biggest teeth. Hybridons actually don't have huge teeth. But this is a really nice tooth that I collected. Now, I'm going to show you that hybridont shark fin spines can actually vary in size. So you've got one like this. This is actually a fully complete one. Actually, this is the first hibernate shark fin spine
Oh,
I
nice.
actually found. So
Yeah.
you got this one, and then actually very inside you got to that, and they get bigger. That's not complete; it's missing the tip. But then they can even get bigger. I've seen specimens in the field where they're absolutely massive. You get ones from Morocco,
Yeah.
which are huge. These dwarf them. There's the ones in Morocco. But what I absolutely love is, so I think so far from the Isle of Wight there is about 3 or 4, 5 species from the Vectis. And I think that's also including Hastings.
Yeah, like currently named. I think there are one like more out there to be kind of described,
Yes.
aren't there?
But what is incredible is the morphology. So the morphology is the different structures and different the way they look. So you got ones that are quite robust at the front, actually dorsally. No, ventrally they're quite robust, and then they've got these weird pittings on the side. You can't actually see them. You might need like they're quite hard to see. And then you've got small ones that are more recurved. They actually have hooklets at the back on the side of them as well. Yeah, they're quite hard
That's
to
cool.
see.
Yeah.
This is the one I actually found with you, Ben. Actually, most of these I found
Was
with
that
you.
in that video, or
No.
was that before?
That one's this.
That's the one from
Yeah,
the video. So if
so-
you've seen last year's Shark Week
That was last time.
video, when we went to find hybridons on the Isle of Wight specifically, yeah, they're really nice. And when you spot them, so you've prepared these quite a lot.
Mm-hmm.
When you actually spot them, there are just like tiny bits of them sticking out. That's
Yeah.
interesting.
So most of the time, because they're curving, you'll always see the bit that's like you see the curvature sticking out. So
Yeah.
that's a good example. Actually, most of the time that's not actually.
Looks quite prepped. Like it's quite below the surface.
So
you
this
can
one
kinda
you
see on
wouldn't
that
actually
one.
see. What you'll see is you see this first. You see that the fossil is near complete here, but when you get towards the base, the ventral surface, it's actually missing because that's the bit that's been weathered out. And that's the bit I saw first. I knew that if I could see the base, and once you become used to fossil collecting hybridons, which in the Vectis is pretty easy, you notice what looks like the base and what looks like the tip. And I noticed that the base was here, but the tip actually wasn't. So my mind was like, okay, the tip has to be digging into the rock. So then, but the question is, at what point do I break the rock to find the fossil? So you can see a crack running through
Broke it.
the fossil. Yeah,
Nice in half.
it
Yeah.
had broken in half.
I mean, I do that all the time with the ones that I'm trying to collect. I'm never very good at actually getting them
See
intact.
the hooklets on there, but
Yeah.
But the best thing is glue is your best friend when you're a paleontologist
you've,
and fossil hunter. We actually
yeah,
have
there
some
we go.
glue just on the side.
Just some good old Loctite. There you go. That's what you need. Good for getting these back together.
Professional paleontologists in labs, they would use epoxy and they would use
Yeah.
paraloid, but that's another debate. But yeah, just showing how incredible these fossils can get. One thing's amazing is you'll always find these fossils deformed. This is what I was going to show Ben now. You can see the pits there. They're like
Yeah.
They're like bumps. That one has hooks.
So
actually
you
see
can
the
yeah
hooks
you
on
can
there.
tell the different species.
Yes,
and what
depending
they
on
are.
that. This one's actually my favourite. It's missing the tip, and it's missing the bit of the base, and it may just look like a really rubbish piece of a hybridon. And I don't think that's true, because you can actually see the scar of where the insertion into the body would be. So the hybridon spine is sticking out of the fin, but you can actually, if it's going to shine,
I think you can see a difference there.
it's...
Yeah.
Oh, I'm pointing the wrong way. Is it there? Wait, yeah. Trying to see how this works. You'll see like a bit of an incline upwards.
Yeah.
The bit underneath is what's going to be in the animal. This is going to be up. So you can actually see the seat going
Yeah, that's
up.
really cool.
So
Yeah.
it's one of my favourites. A lot of the time they get so abraded, so weathered down, that you can't actually see what bit is what.
Yeah. And then you've also got a Moroccan
Yeah,
specimen. So you can buy these whenever you see like a shark teeth for sale in fossil shops. It's usually going to be a Moroccan one. Did you say this is this Otodus obliquus?
I can't remember if this is Otodus obliquus, and I'm probably going to get schooled by someone saying actually it's not. But I remember one of my good friends just gave this to me. He went to Morocco, collected a few, bought a few, and he gave this to me. So I thought it was really nice.
It is
it
a
would be
very good
amazing
one.
for Shark Week.
Yeah.
It just shows. Can you feel how pointy it is?
Oh yeah, it looks like it, and it's actually got all of the lateral cusplets, so you can see like the main crown there, and then the cusplet there, and there's even smaller ones to the side of it. So
you can't. I don't
Very
know
cool.
if you can see on this one. This one actually has cuspids on the side as well. Actually, it might have been better doing that.
oh yeah,
They're really hard to see. It just shows how small hybridons are compared to if this
Yeah.
is. I can't remember, but if this is Otodus,
Yeah.
this is from the phosphates. So they constantly just
Yeah.
take out material that they don't fully know if it's from the Cretaceous deposits or if it's from the phosphate deposits. But once you're working with mammals in the phosphates, you're not in the Cretaceous anymore.
I do actually have a big collection of more shark teeth, but they're at home, so
They're in storage.
I don't have them here. Yeah, but yeah, I hope you enjoyed this little look at a few shark fossils. We've got many more that we can show in future episodes if people are interested. Another Shark Week special perhaps. And yeah, back to the rest of the episode. All right, well, I hope you've enjoyed this shark special so far. There's still plenty more. There's still plenty more videos to come for Shark Week. Well, 2 more. We got the Bracklesham. We're going to Bracklesham. I don't think we even mentioned that.
We did at the beginning.
But I didn't think I mentioned the place.
Oh, okay.
Yeah.
We're literally
where's the
leaving straight
book?
after this.
Book is over there with the
Yeah,
producer.
anyway.
Charlie,
We're going to find some really cool shark teeth, hopefully.
Hopefully.
And then we got the Megalodon one against Leviathan.
My
Everybody.
goal is to get an Otodus obliquus tooth
Oh, yeah.
or a bigger Stratolaria tooth. That one I got there is like almost 3 centimeters. I want bigger.
Wow.
I'm gonna go
Yeah.
against them and find a crocodile tooth.
No, it's Shark Week. You gotta look for the sharks. I actually want a ray dental plate.
Yeah,
That'd be
the
pretty
ray
cool.
dental plates look cool.
Yeah.
I'll allow it.
But yeah, you wanted to talk about our future plans. We just want to do more boneheads basically,
Yeah.
and I want to do more regular videos. And I've also got plans for 7 Days of Science, kind of upping the production. Now that I do have more time now. We're not doing many different university projects. It's just a master's research project, which I can manage doing more video stuff.
We have a
It's
few
just-
side projects on the line.
Yeah, we got side projects too. In terms of boneheads, it's just we try to do it every couple of weeks, and I think we can probably
Yeah. Hopefully.
we could once we get into the rhythm of next year, we can definitely manage that. It's just for now, it's like our schedules keep kind of we're not all here at the same time. So.
But let us know what you want to see as well.
Yeah, definitely in the comments below. Give us any sort of suggestions you have for boneheads videos because we are.
We love doing them, and
Yeah, we want to know what you enjoy the most. So obviously we've still got the Germany special. That's just going to be like
Oh, just how fun our trip was,
Yeah.
what we did,
it's
and
incredible.
it's just going to be us.
it was a load.
looking
It
at
was just a load of
museums
fun.
and-
I mean,
And
Yeah.
do you know what? I was actually recently thinking about this. I would love to go back. I would love to
Yeah.
go back to
I mean,
Germany.
speaking of sharks, we got to see the hybridon with all those belemnites in its stomach.
Yes,
Yeah,
we did.
That was cool. I'll put an image of that in.
Trying to
must
think
have
any
taken
other
some.
sharks we saw in Germany. See any others?
There would
Lots
have
of
been.
hybridons.
Yeah, mostly hybridons like Posidonia.
Although in
stuff.
the Stuttgart Museum there was like a reconstruction of a megalodon head, wasn't there?
Yes,
Yeah,
I've
is that
used
the
that
one-
video.
Is that the one
in
coming
of
out
my
of the
videos.
ground?
Yeah,
Yeah.
that was cool. That was very nice. Took many photos next to that. So yeah,
And you couldn't climb into it.
I know. Yeah, I wish I could have actually. That would have been great. Yeah, so we got lots of cool stuff planned. We've got we'll do more fossil hunting trip segments.
Definitely.
Do we have one?
Planned?
Didn't we already record one? Am I thinking of something
I
else?
swear it was a Wessex formation, a Vector's formation.
It might be.
That's what I'm saying.
Oh, we haven't even done the Patago Titan stuff yet. We have a trip.
we haven't done that.
No, we have. Okay, so that's another thing.
Oh wow,
So-
that's a big thing.
We've got 3
ages ago.
museum trips we've done and filmed as 4 segments for Boneheads, but we haven't done any Boneheads since. And this is obviously our Shark special. So over the next few episodes, we'll include those. We went to see the Patago Titan display at the Natural History Museum in London, which was
Don't worry,
amazing.
NHM, we're coming back. So
Yeah. And we went to Cambridge and we went to Oxford. So the museum's there. So we'll be showing those in some future episodes.
There's no lack of content. It's just putting it together.
it's
Yeah.
what we want to do.
But definitely let us, give us ideas for
Yeah.
topics. We will be doing more news coverage as well. I think that works quite well when we talk more in detail about recent papers. I think we need to stop trying to cover absolutely everything that comes out in a week and
Yeah.
focus more on the ones that really interest us. Because that's what 7 Days of Science is, for covering everything. We can go into more in depth on stuff. So let us know if that's what you would enjoy seeing. And just like, you know, episodes dedicated to one topic. We had the idea, or you had the idea of doing episodes dedicated on a singular formation and kind of the whole environment, all of the animals you find there, what the type of preservation is like and everything. And doing like an entire video on one particular fossil formation would be kind of cool. So yeah. Yeah, thank you for watching.
Good to be back.
Yeah, it is. And I hope you've been enjoying Shark Week 2023 so far. Give us ideas for Shark Week 2024 as well if you want.
Thank you for allowing BoneHeads to be a part of it.
Yeah.
Cartilage head.
Cartilage heads for this episode. Yeah, so thank you very much for watching and see you next. Bye.